Stream Element bot is not working. Well, not on YouTube at least. Oh, let's hope we don't get mad spam with weird, with weirdos, right? All right. Oh, okay. I'm gonna reduce the music just a bit. There we go. Oh, how are we all doing? It's a Monday. Been a while indeed. I need to enable. Oh, there we go. Because I put my cameras on this toggle thing. No, KVM, not KVM. Just KV. There's no M. The KV switch. Yeah, so I can switch between my day job and stream. Sometimes it doesn't work. Sometimes it just stuck in the middle. Yeah, I'm just glitched out. I'm just gonna test it. Okay, let's go here first and foremost. Oh, damn. Man. I really need to find a way to do more exercise. I don't have time for it, literally. Woke up, get some food, do some cleaning, and here we are. Already have to start a stream, and I'll probably be here until another 8 hours. Alright, this is the latest part coming out of the for the what do you call it? Printer. I'm just gonna remove all the support here. Something that I made recently. Finally got around to it. I make a scraper now. Oh, no, I grabbed this scraper from Printable, and it used one of these utility blade as the thing instead of just a piece of metal. Not sure how I feel about this. It's a good idea using the utility blade, but on paper, because it go down and it just allow me to just scrape almost everything off the bed. The problem with this is this utility blade is actually it's too effective. So if you scrape too hard, this metal here actually scrape the PEI off the sheet of the sheet of the PEI. It may scrape the PEI coating on the build plate itself, which is not good. Unfortunately to me, I'm not sure how to feel about this. Good thing I didn't pay for it. Maybe it would not be as bad if I use it a bit longer and the play itself worn down. Also, flinging this around is a little bit dangerous. Right. Let me just clean that bit there. Back in. Oh god, every fan on this machine is dying. Literally all of them. I guess heating things up too hot, making it giving it a high temperature long period of time was not the best idea that I had. The best idea that I have had. this thing needs an indexing tab. Cool. Well, the funny thing about this thing is that you can use this as a like a makeshift chisel. I'll just say that, but that's an idea for later. For now, this guy here, in here, you can see this little tab here. I just and this thing here, just pull that off. This is meant to be broke off. Nice that. Oh, it work very well if I do say so myself. 3, 4, sorry. Now I need to be careful on where the hell do I put all the tab? We don't know which one is tab, which one is just, you know, part itself. The auto-generated support is easy enough to peel off. So, this is tab. Alright. These are here because if I don't, this bridge on the top gonna pull the print into itself and ruin it. You still see some, yeah, it doesn't help the whole way because I can still see some line right there where the wall got pulled in a bit, but it would have been worse if I would have for this tab. So just have to keep it like that. That's the best we can do now. Printing big things is a little bit annoying, can be annoying sometimes. Alright, so I'm going to use this tape scraper thing here. Just also remember, this is also a piece of plate. Not sure. Dun, dun. Dun, dun, dun. Oh, it's a bank holiday today, so that's why I get to work at home. No, not work at home. I would say why I get to not go to work. The annoying thing is, unlike my old holiday policy at my company, because my company got bought out by another one, so we have to use their holiday policy now. But the new policy does not take into account of regional differences. So they don't. No, so the old company had old policy flexible. They give you a number of days in accordance to what you have in public holiday, and then you can take it whenever. The reason why they did that back then for the old company is that it allow you to schedule yourself. Okay, so like for this region, for example, like what's it, July. In July is the Norwegian holidays. So what I what I used to do is that I would make July my own holiday as well, so that I line up my holiday with my bosses, sort of. Which that way there's no need to go and trying to manage a whole load of like people in, people out kind of thing. The new company don't do that. They just told you to take the public holiday when they come, and you don't have a choice on it. You take it or leave it, right? So what ended up happening is that last Friday was Indian holiday, Indian bank holiday. So they took a day off, and yeah, we couldn't get in contact with that. And then this morning, this Monday today, is UK bank holidays. So, oh no, I have not been able to get in contact with my Indian colleague for 4 days now. Given that not horribly flexible, this new system. It is simple to manage. I give them that. Which is probably why they do it this way in the first place. Not very effective. Well, won't complain. I won't complain too much, because I know it's still a holiday. It's not like on a personal level. It's like, hey, you gave me a holiday, I'm going to take it, right? All right, that's it. No, let's just finish that one. Yeah, the problem with the built-in support, because that one is quite intrusive. Is that I have to go and try and scrape some of the residue off after I'm done. And I can also tell that this thing is slightly warped on the bottom here. Once again, that's not something I can fix really. So the thing that we're testing right now, this very moment, very important, is this dub tab here. See this groove here. Let's see if it worked. And adjust accordingly. I assume that it will. Wait, and line it up. That's gonna be tough. Alright. Mallet. Rubber mallet. Hope that's gonna be redesigned anyway, because I'm already on to do new stuff. So I'm happy to just do a little bit, get a little rough with it. That's it. Maybe I should have done two. Move this so I don't break my own server. I might want to increase the tolerance in those grooves a little bit. No, because there's three, right? There's three. There's one here, one here, and one here. And because they have to go down in parallel, they don't go down in parallel. That's the problem. This as well. So trying to persuade it in with a hammer and hopefully don't break anything. No. Wait, what? Does the hammer sound come through for you guys? Let's see. And 1 and 2 and oh no, good. You guys don't hear it. That's good. Yeah, I'm hammering this in. Ow. That hammering aside, both fit with too far. No, the fact that I'm needing the hammer aside, this thing fit perfectly. To be honest, I take it back. I'm not gonna play with this. I'm not gonna tweak this. Oh, and there's the low channel thing still working. Sort not too well. What is it? The thing I noticed is that if I push on this little lid here, you can see the doors flexing out. I'm not sure to keep that as a. It's very convenient because that's allow me to just rip this trap door out if I needed to. So I don't want to get rid of it just yet, but I also can appreciate that it's not exactly up big in terms of quality. Which you can just the door like that, right? I'm not sure about that just yet. Well, we'll see. Okay. For a second, I thought something is popping up on the stream notification. No. Nobody watch at this hour, especially on a Monday. I'm taking stream to myself here. Okay. And this thing needs to go like that. Holy hell. Looks so damn good. Other than the part that's all black. Other than the part that when it's all looking black. Oh, okay. The one thing that I'm worrying about is this little thing here. These are magnet holder. And from the look of it, it seems like I'm gonna need a lot of glue to keep the magnet in there. The hole is much wider than it's supposed to be. What else can I have? I noticed. Oh yeah, let's test the nut in a minute. Gonna test the nut out in a minute, and then No. Honestly, I'm trying to think of the reason why I should hate this, but I can't. It worked very well, in fact. Oh, well, other than the magnet holder. It doesn't. That doesn't seem too good. Other than that. Why are you making that weird shape? Yeah. Let me just try to trim. Let me just trim this down just a little bit. Need to be careful here because I'm working. This is ASA, and ASA is more brittle than ABS. That is to say, trying to cut it, and it's not gonna cut through like ABS would be, like butter, which is the same way ABS would do. What it's gonna do is that it's just gonna get hot top in the middle, and then it just pull through right at in a second, which is very dangerous because the blade can go straight to your finger. Be really careful with that. And yes, and no, the black coloring here is literally just because this is a prototype. For all intents and purposes, I'm gonna get rid of this at some point. I'm hoping to make a video about it before I prove it out, but oh, do I have? This is like you guys see all of this, right? So much prototyping already going on, so I'm not sure I need to keep this one specifically, or any of these. To be fair, this version is going well. Huh? I think I'm going well. I think I'm going well. I have finally come around to sell off my Steam Deck. I got one of those first generation Steam Deck. Bought it, played with it a lot over the years. But the battery is dying, so I was like, okay, time to sell it. And luckily, and I have and I stacked all the money to buy all the components for this thing. So they are in the mail, hopefully by Saturday. I'm gonna come by. Wait, no, not all of them gonna come Saturday. Some of them gonna come later in the month because it got shipped from America. It's gonna be an interesting exercise to try to fully insulate. No, not insulate. Yeah, just trying to insulate these chamber. Not insulate, isolate. Trying to make it airtight between the chamber. But you can see that all this all groove over here. All this gonna get air sucked into this chamber without passing through the filters, which is not good. The amount is a percentage, I suppose. Like how much you willing to take, how much that contamination are you willing to take, right? Oh, I know even the corporate filtration system doesn't do that. Doesn't seal that chamber very well. There we go. All right. Let me take this thing out. Let's just put the nuts in and actually assemble this thing regardless, because we need to know. We need to know about every hole and everything in here. Speaking of every hole, okay, never mind. I already changed it. So never mind. So there's the nut is down on this one is up here, while the hole on this one is down here. Down here. That makes sense. So I already changed the design halfway through, so I can't put them this thing together. But they're gonna go something like that. Yeah, there'll be a grid here just to hold it, make this thing a little tougher than what it is right now. And there will be a hole in the bottom of this. Hole in the bottom of this to mount to a another piece. So anything I can do? Other than putting a dovetail. I was thinking about doing the same thing I did over here with the dovetail. And just put it here and put it here so that I can smash these two pieces together. That is something I could do. I mean, should I be bothered? It would be harder than it looks. The reason why I hadn't done it because these two piece part here, the left and the right chamber here, are designed as a single piece. So, and for the DT stuff to be made, I need to intentionally leave out a gap in between them, so that they can actually fit each other, like the one on you see on this side. So if I want to put dovetail on this, basically I have to take the current design as it is, as they are right now, and make another clone of it, and then put a dovetail on them manually, which is not exactly pleasant work. And once again, I'm not sure that is necessary because I got all the hole and all that here that I need. So maybe not. That is something I can do for in terms of like what is it called, unity, design consistency, but it's more aesthetic than it is functional. That one, putting dovetail on this like that. So let's not do that. Yeah, let's not do that. Anyway, we got this. On was good. The good news. Honest, this is the best. This is the best bit of this whole day. I know I'm starting. This is the best bit. Actually, let me do this really quick to shape it. And one thing I noticed that I'm not exactly thrilled about with this design, that this little surface here need to be carved off a little bit to fit this the tip of the fin, because when I printed the body of the flow controller just here, this part, I didn't account for where the seams are. So right now the seam is right where the fin is rubbing against. Well, maybe I don't like. Do I like the way that it is? How flexible it is? Maybe not. Pushing along the little tab that that server gonna get access to in there. And if I want to push on there, it's actually very easy to move. So functionally, I don't need to do anything. Functionally, at least. Right. That's it, though. Yeah. Yeah, because of the wall is still slightly warped inward. So wall is slightly warped inward. So that is why this hole here, when you smash these two pieces together, these two holes in the middle, it's just like it's a bit bigger than it's supposed to be. It's very obvious. So when it comes time to gluing the magnet in there, it's gonna be interesting. I gotta do it now, but it's gonna be interesting to see. I mean, I can always just fill it up with glue, can I? Just fill it up with glue and it's all good. Yeah. Yeah, leave it at that. Leave it at that. There are more important things to do. That's let's see how much. I do have a lot of filament left. It's in ABS though. Maybe I start using different color now. Not gonna lie. Things are getting a bit boring with the black. Especially when the filter itself is black. Okay. Shove it in. Gonna save some space here and just stack the prototype on top of each other. Ah. Oh yeah, well, one thing that I noticed. I don't think anyone here was there when I made it, but I did make a comment about making a fin between these two top and bottom bit here. Totally forgot to do that. So now you can see how flexible it is. So when I put the servo mount here in, it will hold. It will hold. It holds a bit, but it's not secure enough to be comfortable about it. I can twist it. But the key is that I can twist it like that. I can twist it at an angle like that, and it will still sit, but it's not right. So I have to. So what I have done on the CAD, I'll show you in a minute. That I have put screw hole on both sides. So there's a hole there already. See, but then I'll put a hole on the other side so that I can screw both sides together. So that way, this piece in the middle here gonna be the pillars that support these two, that keep these two sides of the filter section to be apart. That's the idea. What else do I need? Right. So next thing to test is the basket itself. Oh yeah, I think about that. Okay, there's two things I need to test. One is the 2.5. Well, two things more things to do. So I need to create the lid that's gonna close up this up. I need to see how because that is the taper kind of design, the taper to seal design that I have in mind. I never tested it before, so I need to test it to see it for myself whether it's working. And I need to figure out the basket here. So not the basket. I need to print out the basket and see if it fits. So yeah, that's what I'm gonna load up today. I think that I'll load up the we load up the seal first, because that one is it's fast. That thing gonna be within the length of this stream. I think I'm gonna make that lid. For the basket, I'm gonna print it out, and that could be a next week endeavor. Like, so I'm not around this weekend, so I'm not gonna do this. I'm not gonna be streaming about it this weekend, but next week. So yeah, that's the plan. That's the plan. So here, I just have a look at this printer here. You see how I took up all the nozzle there. That is also a design aspect of this machine. I could easily do that without. Oh, my back, neck. Sorry. Oh my. Okay. So, and go to the computer view. Oh yeah. Hey, if anyone on PopOS right now trying to open 3MF is a pain in the ass. You can double click that and not gonna happen. What I have to do is I have to go to open with here. OCAD slicer is no longer exists. So I have to scroll down to where's the Brusa slicer there. Open that. Annoying. It's so annoying. I want to get out of this already. Not that I will, but the thought that count. Yeah, so that's plate 2, plate 3. Oh, plate 3 is the grid surface on this thing. Oh, actually, how long does that take? Oh wait, not gonna fit. Not gonna fit. No. So because these two had been redesigned substantially. So these two had been redesigned substantially to fit the new thing. So I don't think they need to. I want to do that one. I want to do this one here. Yeah. The hole should be the same still. Okay, so we shall slash that. Simple enough. Okay. Do I flip it over? No, do I value the seal or do I value the look of it? No, I like the seal better. No, so because this is a slightly tape, shouldn't matter. It should not matter. Yeah, no, let's do this side here. Because this side is what the side that we're gonna get to see. Right, this is the side that we get to see. It's the outer side with the countersunk bolt here. So when we do this, we will see that this is gonna be the have the texture of the bed, which is much nicer than this surface here on top. But obviously, if I do that, it will be but this surface is gonna be rougher than the bottom, which is not good for sealing. But it's not gonna be airtight anyway because it's a texture bed that I have. So might as well do this so that I can have the nicer looking face, and the nicer looking surface facing outward. Right, slide that. How long does it take? 4 hours. Great. Oh, it's already there. It's already there. So let's go slowly break wood here. Oh yeah, one of the things that probably is still missing. I wish to be able to just press the window key or the super key for the Linux folks, and then click and then select a number for these guys. Still haven't got that. KDE have that, and I miss that so much. So I assume. Oh boy, clean that off. Oh wait, 4 hours. Okay, that's UHD and what country level there? Down here, let's heat it up to 40 C. And while it's doing its thing, what are we doing today? Oh yeah, before I can show off what I have done already. So let me show off what I have done now. Oh, wait. I have made like 2 little modifications. No, yeah, so that version that is gonna be printed right now is version 3.3.0, and as you can tell, I'm already moving on to 3. Oh no, I'm already moving on to 3.3.2 for the design here. Oh, second, I thought the software was gonna break. So I make this little doodad here in the bottom. Let's make it highlighted really quick. Gonna turn the color. So yeah, we have a little doodad here in the bottom to hold it. And there's an indexer. This is what's gonna be mounted on the bottom aluminum extrusion. There's some hole here for magnet on both sides. So I'm gonna put some magnet in here, and they're gonna just go click into place. This way I can index this hole specifically. The function of this is this hole specifically need to be lined up to the outside world one way or another. And yeah, so I'm gonna have to order soon. I have to order the side piece with a hole for this. I don't want to drill my own, so I'm gonna have to order from Fiberworks. That's his name. Yep. I need to order a side the side panel from him with the hole cut out for me. So oh yeah, in that case we need to make, oh wow. Might have to drill my own. No, so it's not hard to drill acrylic, right? The reason I don't want to forget this, but it's if it is the only acrylic panel that you have, it is really daunting to do anything to it. If this is the only printer someone have, having to just take what I have perfectly functional and potentially break it is very daunting. So I might have to drill my own hole, cut out do my own cutout. But how we do this? We could leave it for another day. Because to be honest, to be fair to me, I hadn't even really decided where I want this thing to be mounted on my own printer. That's the problem, huh? You know what? We'll do the CAD for the panel later. It's a simple CAD, but the daunting task to do it on your own printer when you still haven't finished design. So let's not do that just now. Wait, so this is the thing that this panel here is what we after. Yeah, that one, right? Oh, not that one. Where's got build main lid there? Well, that one is the one that we're printing right now, and these two are what come next. Be interesting if this one work. Okay. Sometimes you wish that I have more than one printer, that it's functional. Because right now, if the machine, if V1 came down, but if V1 fail, I am screwed. That's it. Look at that bad boy. I'm pretty happy with this. What is it? Servo mount thing. So I gotta put the servo back in. Yeah, like that. Yeah. So instead of using the hole that the servo have for it, what I'm gonna do is I'm gonna shove the servo into a groove cut out right there, and I shove a piece that's foreign piece. Servo mount, yeah. Double transparent. Yeah, I'm gonna shove that thing in there and just hold it in place into that groove. So that way I don't have to go just maneuver my way down and trying to work with the hole, the mounting hole from the servo itself. So hopefully that has a good design. Oh right, this oh what happened here? Something broke. God damn it. Trapdoor. Yeah. We want to fix that anyway. Yeah. God damn it, what had going on? What? Oh damn it. Okay. Yeah, I thought I'm going to move on and do something else. Put that away, put the servo away. Okay, there's a broken surface right there. That should not supposed to be there. But that sucks. How to get rid of that? Why is it broken though? Yeah, that's fine. Oh, hello. Oh wait, no. Yeah, no, that's fine. That's fine. That's fine. That's fine. Why are you? That is fine as well. Let's go in here. Right away. First of all, what I need to do? Do I need to do this? Let's see. Because the hole currently is slightly bigger than it's supposed to be. It's a 2 mil square hole, while what I need is 1 mil. So I reckon I'll just reduce this to 1.5. Yeah. 1.5. So make the hole a little bit. Yeah, the whole thing is slightly smaller. For 1 and for 2, I still do not understand why it do that. I do not understand what is going on. Like that. Okay. What's going on? What is going on? I don't know what's going on. That one, everything correct, right? Everything seems mildly. Everything seems right. Why are you broken? And it's just a sketch. This is a servo. Okay. Is it a warning about this? Internal sensor. Actually, no. This one. Yeah. Map correctly? Yeah, it does. Cancel. Wait, why is it broken? You can see that right there, right? That's where thingy. It's right there. What are you designing? Oh, I'm building a filtration system for my 3D printer. So I am, what is it called? What is it called? So this guy over here is a Voron, and what is a 3D printer? It's called Voron, and what is it? The thing with 3D printer is that it's melt these filament here, and this filament, there's this row of filament into like shape and all of that. But the problem with it is melting plastic create off gas, like a lot of fume and nothing going on. So for the old printer that I have with me right now, I got this big boy on the top and a small boy on the bottom, where it's filled up with carbon pellets. Yeah. Oh, I think it's not coming out. There we go. Yeah. There's this little basket here that I put in the machine to just suck in all the fume, and I don't think you can hear it, but yeah, there's carbon pellets in here to filter it all out, all the bad stuff. It didn't work too well though. This little basket is too small. So what I'm doing is I'm gonna make something much bigger, using a commercially available filter here to try to clean up the air in this second machine. So yeah, in fact, it's gonna sit somewhere right there. Sitting somewhere right there. It's all black now because it's a prototype, but I swear when I'm done with this, I'm gonna make it with a good color. So any one of those color. So yeah, that's the idea. Of course, in light of the edition, if you may even call that, from the commercial space, I'm gonna put a servo in here. Just have it able to either blow air into the chamber or blow air outside the chamber, so that's cooling it down, basically cooling it down. Oh yeah, that's the plan. This thing is actually harder to do than the tool changer a bit on the top, because it's so big that the filament warped. Filament warp as it's print, and it's because it's so big, the warping is strong enough to just lift the entire bed off the magnet that it's resting upon. Oh yeah, right there. Good thing I keep the prototype. This is not the part lifting off the bed. This is the part pulling the entire bed upward. So this whole little art here, I had to redesign it so like several times already. But we finally got to somewhere good. Anyway, why does this take so long? Oh yeah. There we are. Oh. What was it? Yeah, I was hoping I got him. Was it? No. What is it? Oh my god. I sold my Steam Deck yesterday. That's a little, yeah, that's very cool. I had a little knowledge of 3D printing and CAD, but only a very simple thing. Ah, yeah. No, this is just, what is it? Sorry, my brain got messed up whenever I move around a little bit. But I have very little in the false hammer video. What is it? Oh my god, I couldn't use that word too often. I'm messing up my wording there. YouTube false hammer. Yeah, I'm good with CAD and all of that, but there are other things that I'm bad at. Really, no, I'm get humble really fast when it comes time to use the machine to do creative stuff. I can make the machine, but I'm not good at doing the creative stuff with the machine. So what humbled me recently is actually this video here from False Hammer, if I can find it. Goddamn YouTube. 3 minutes. Oh, False Hammer. False Hammer. Hammer. Channel. Yeah, we go. There we go. This is nothing to do with 3D printing. Oh, it is 3D printing, but not the way that we would have liked to the normal know it of. But this one here. Yeah, so this is the this channel here from of False Hammer.
Here we are again.
Yeah.
With one...
He took he took a UV resin printer. And he started making stuff with it for his review, and it's not the I would never buy this, not because I spent it, because I don't know what to do with it. Right? And the reason why that this video humbled me is actually this part here. You need to be able to do that. I don't know how to do all of this designing. I can do 3D object for normal things, but when it comes to art, it's can't. So, oh, you win some, you. Oh, sorry, can't see the video. There we go. Sorry, my bad. Alright, so creativity manifest in different way. Creativity manifests itself in different way. You just need to find your way. That's what I'm trying to get at. With all the yapping and repeating myself. Yeah. So yeah, this lad is use this machine here. Yep, the UV make UV printer. He make all sorts of cool stuff with it. Well, that's not the point of his channel, but yeah, what he had managed to do with it within the review period humbled me quite a lot when it comes to my creativity. Oh yeah. Hey, I'm just gonna sit in this corner and keep making my 3D printer, I guess. With that said, it's almost hot enough now, so we need to go and find. That's right there. Okay, the one is done. It's gonna start printing that, and it'll be 4 hours. I cannot make it any faster. If I make it faster, the bed actually the part gonna be warped so much that once again it's gonna pull the entire steel plate up with it. So that is that. We'll move this one down here. Wait, no, I don't need that. Save. Alright, so where was I with this? All right, yes. Free cat, what are you doing? Oh, what? Yeah. I don't know why it just stuck like that. This little rectangle, no, square there is not meant to be there. I do not know why it is there. Trying to think here, what could I do to not have that? This is one of the simpler part too, so it really there's not that many revenue. Yeah, I know, right? It's just like, okay, for one, for at least it's one of the downstream part, right? So if I edit it now, like if I actually save first, always save. I save it, and I'm gonna delete this now, and then I redo it. Reverse. Okay. Oh, wait. You see that? But this worked fine. Yeah, the surface works fine, but if I reverse it, oh yeah, there's no surface anymore on top. How are you doing that? Is it? No way. I'm not. I'm crazy. I'm just being crazy, right? Probably crazy. But if I reverse it, no, no, no. I was not crazy. You can see that it's the shade of the surface is changed slightly. So there were no. So there's no surface if I do it the other way, for whatever reason. What the hell? Oh no. Okay, never mind. It's still broken. Ah. Okay. Did that. Why are you doing that to me? Oh. There could be here. One sec, one sec. Hold it. I there's something I want to try. I want to get rid of that point there. No, because there could be a point that could be that the this line here is it tracing along the bottom surface here. There's two surfaces laying on top of each other basically. So there is a chance that that is what caused the confusion in the software. It was like, wait, there's two surfaces on top of each other? What do you mean? Okay. So I need to go and hunt down this specific. Goddamn. Come on. Oh, that one. There's 6. Alright, so I remove that. It happens sometimes with this this software. Okay. I need to hunt this one down as well. Oh, that's that right there. There we go. Let's move it up a little bit. Dimension. Give it, I don't know, 100 micron. Just and make that parallel. So lock it in. Close that. And now, can I extrude that? Reverse. Okay. Nope. Still. And how does the bottom fail too? So that's not it. How about this guy here? Whatever happened wrong is wrong. Is wrong with oh wait. I'm thinking. Let's delete all of this. Not that one. Because all these construction lines are there for me to make sure that everything can actually move, right? But I don't actually need it to be there for the extrude. What I need is this final number here. To be fair, it's actually very robust in terms of like what kind of stress it can handle. So I'm not too concerned in terms of it being being unable to being unable to actuate by I'm not concerned about it being unable to actuate under the using the servo. Why are you doing that? Oh, these two are parallel, but that one needs to be parallel to that one. There we go. I want to give this gap here more number. Dimension. And gap dimension 0.1. Well, yeah, like that. And this one, oh yeah, because I removed the other one. That one should be parallel. Gap wise dimension. Yeah, you put one gap between all the potentially probable cause of the problem. There we go. So it was that one. So it was that little gap there. Caused the problem. Why did it cause a problem? You goddamn know. Probably something weird with having this face, and that face just join up into a single point that caused it. What I can do is make it 0.5 instead. Just have that. I don't want that gap. I don't want that gap. Probably would have spent 20 minutes on just that. Yeah, no. I said the reason why I know all of this because I spent days on it at one point. So this is FreeCAD 1.1.1, which is a very updated version of FreeCAD, and a lot of this now no longer causing that much problem. But it used to be that even if I change a slight number like that would break the entire model, right? The entire model would need to be reworked. But I spent after like a year or two just doing that. I just grown a sense of know where everything is and fix it. And even to this day, I'm still using some of the tactic that I had back in the day to try to keep it as stable as possible, even though I don't need it anymore. I'm making tandem plane and all of that. Oh, it's good. Oh, it's good. That is that. Now, funny enough, I have ran out of things to do on this specific system. So now it's just a matter of just waiting for the thing to print, fix whatever broken with the what I found from the prototype, and then deal with it. Right, so all of this needs to be printed out, and honestly, I only have 2 of them printed out thus far, and both require printing adjustment, which I already done. So what I'm gonna do today, nothing to do with this project specifically. I'm gonna work some CAD work on another project that I have been having in dormant for a while. Let's just make sure this one is safe. This is everything that I want, and it is. Get back to it hopefully next week when all the prototype came out. What I want now is the mechanism wheel. Ooh. Oh wow. Hard to say, I was very dedicated to this project at some point. Okay. Let's see how to do this. Copy that. Yeah. Oh no, that goes for 0.3.0. Alright, mechanism wheel. There we go, this is it. This is what I'm gonna get rid of. So I printed this one is what is it? For those who don't know, the mechanism wheel system is with this roller here at a 45-degree angle. When this wheel spin along this rim here, when this thing is spin around here, what happened is that these roller will allow the wheel to travel at a 45-degree angle. That's the idea behind mechanism wheel. This current design here, I have already printed, tested it in the wrong material, mind you. But what I do find annoying about it specifically is one, you see the little gap between there and there, this gap here, that's too small. That it's like a 1 or 2 millimeter here, and what that means is on any other surface that is not like flat concrete, this wheel gonna get all seized up and fail to work. And that tire there, that purple tire there, it's eventually gonna wear out. And this and yeah, it will wear down to this plastic part extremely fast, unfortunately, on a real road. But now I need to rethink this. Kind of annoying that I have to, because as you can see, I already done all the necessary design work to make it a great 3D printed object. I have no clue where. Also, this whole design is super heavy. Trying to think here. Was yeah, no. Just, I'm trying to. I was hoping that I can save this. I don't think I can. It's better off to just start from a blank slate. So I'm just gonna get rid of all of the one that. Oop. Get rid of all of my old file here. Save this. As mechanism wheel. Where I got? Okay. Wheels design make and oh, it's printing. One sec. Oh, I need to check first layer. Nah, that's fine. Perfect. It is perfect. The first layer need to, because in a heated chamber, the first layer can always be a little dodgy, because the metal flex and the metal expand under in the heat. So that's why I always have to go and check if it doing this job correctly, the whole compensation system. All right, so now let's go for that. Thing we need to do is create a body. Let's call it. What I'm doing first. Let's call it axle reference. Roller axis. Roller axle. Hey Google, how do I spell axle? No internet. Screw you. Roller axis. Expose the origin really quick. The way that axle low. Hey, it's not my first language, alright? You can't fault me. I'm worried for not being able to know the word in my in a second language. Okay, there we go. Axle. Alright, there we go. Alright, we need to create a tandem plane in a right face to that. Come on, let me choose. Goddamn. No. Okay. And let's just grab a tandem plane here and select that face. Not that face. There we go. Origin plan, yeah, okay. And now we're gonna spin it. Yeah, on the z-axis. Yeah, let's go to the z. Let's do the z. For 45. 45. Eh? What happened? Oh. Okay, one sec. That's not it. Put that to 0. Yeah, that one. Is that the y then? 45? There we go. Yep. 45. Oh, come on. Wait, 45 here? Oh, you have an ender tree first layer always. What fell on my print? Yeah, I have one too. It's right on top of the cupboard over there. And that is also the reason why I can never touch it again. In fact, the only reason why I haven't dragged it into like charity shop and just give it away, because it's too heavy. Yeah, an ender is what I would describe as a the starter kit. You don't stick with it for a long term. No, that's like a bad idea. So this damn thing is just failed. All right, we need to draw something first. Yeah, ready to upgrade low. Have limit it by now for too long. Yeah, especially nowadays, right? Especially nowadays in terms of like upgrade, you are spoiled for choice. Back in my days, oh god, I say old. That make me sound old. But back in my days, the ender was the only option. Your only option, not only option, sorry. Your only option were options were the ender for very cheap, Prusa for so like productions work, and or Voron if you want to build if you just want to take it to your own hand, just build it yourself, right? Both the Prusa and the Voron option is extremely expensive, even to this day. So nowadays you got Bamboo Lab, you got Chidi, you got Anchor, and even the Ender people, they still not gonna have good quality control, but they have better options nowadays. What was I doing? No, I take it back. I'm trying to think here, but all right, let's draw on that. Come on, get me to the middle. Here we go. Yeah, I got I got my ender around when they came outlaw. I think I'm gonna go to Voron or Bamboo next one and afford it. Yeah, replicate the MakerBot was a big one as well. Yeah, oh yeah, no, actually that is older than my days. No, because when I say back in my days, I literally mean less than about 5 years ago. Back then, at that point, 5 years ago, MakerBot and Replica is getting out of fashion as far as I'm concerned. Like, why do you want that? If you want, oh, what's happening? I'm trying to figure out what's going on with my drawing here. Getting weird, no? Yeah, because I'm drawing on it, and was it an angle of surface? It's doing that. God damn it. All right, let's delete them all. Get back to that. I'm gonna delete it and redo it all. Wait, no, wait. One last check. But one last effort. Let's try. Okay, there we go. Do I count that as a freak? Oh no, it's not. Yeah. So come on. See? Connect, yep. The axle are 5 mil. Dimension. Yeah. Yeah, where is that? Okay, that is one thing. Why is it so dodgy right now? Where's the sketch that I just have? Replica was one of the first that wasn't a project itself. It's a tool that actually did stuff. Nowadays, 300 euros, Bamboo, absolute demolish it. Yeah. But the funny thing about Bamboo nowadays is that what is it? The thing with the 3D printer in as a product, right? It's strange because it's such a flexible tool that the people who use them can have so much like have polarizing opinion on every side. So the one that I'm thinking about is right now is the Bamboo X2C, the two nozzle the cheap two nozzle or dual nozzle system that I came out recently with the what it called reverse Bowden, the Bowden feet. For me as an engineer, I look at that and I go like, that is a lot of stuff that's a lot of good stuff for engineer. No, for the money, right? Because for me, I'm all about the multi-material. No, not the direct drive. The Bowden feet also. Let's go there. Bamboo to X2C. To see, yeah, this guy here, right? X2D, X2D, sorry, X2D. Oh, yeah, a dual nozzle system here. The one on the left is direct drive. The one on the right is the Bowden feed. That's the Bowden system. So Everyone give them a lot. Oh no, some people find that annoying because they don't like bow and feed, and other people, me included, find that to be a rather good trade-off. Because personally, I don't care about multicolor. Personally, I don't care about multicolor. In fact, my whole stick is about multi-material. And one key thing with multi-material is having a support material, right? So if I'm printing PDG with the left nozzle here, the right nozzle can be printing POA for support. And if it's support, I don't care that much about the quality of the support as long as it's thick, right? So folding feet on that one is actually sound just about right. The only thing that I'm still gonna continue to criticize Bamboo about on this machine is the fact that TPU don't work on them, and that is half the reason why I even want a tool changer in the first place. I want to combine TPU, the soft material, with something hard material, right? That is what I'm doing right now, in fact. So if I go back to my other, okay, I'm not sure what's going on here, but I'm gonna delete this roller because it's broken for some reason. I'm gonna open the old one really quick. Oh wow, yeah. So you can see here this grating in the middle of the wheel here, that is designed to be a nylon or some low friction material core, and then the purple part is TPU. I want to print both in a single unit. I don't want to have to press fit cord into this TPU ring. It's a very long ring. This thing is like what? This thing is like, yeah, this is like 60 millimeter. There's no way to press fit a cord into this wheel without damaging something. That's what. So so without the ability to print TPU, any Bamboo system is dead in the water for me. But I can still appreciate the ability to combine PDG and POA, because I believe those are the two most common material in 3D printing, right? So I thought that would so I thought for sure that the X2D would have capture a lot of attention. Apparently not. Apparently people hated it because most people don't want multi-material. They want multi-color, which just mean a lot of nozzle. And that's it. A lot of nozzle and a good control of it. Oh wait, no, not up here. 0. Let's try that again. I don't know why it didn't work. Oh wait, actually, what I should do before I make that one. This new gantry, no, this new XY gantry thing it's less intrusive than the old version, but with me and my old man eye, look at this, I have a hard time trying to find where I am in the space. So where the? Why is it? Okay, there we go. Yeah, what the hell is this? Oh, come on. Yeah, why? What? What is this thing that they put? Oh my god. Close that. It's been a while since I. Okay. Try again. Come on. I can't even zoom in. That's annoying. That's the annoying part. I can't even zoom in because it's scaled to the size of what I'm doing. Okay. Why does this look so weird? Alright, just draw a giant circle for me. How are you doing? Yeah, you guys in this? It's definitely a free cat, bro. Oh. Put me into a different orientation scene. Right, so if I do that, and alright, there we go. Okay, there we go. Alright, I think that's the right orientation finally. Yeah, this is buggy as hell. God damn it. What am I looking at? Come on. I just want a sketch, man. Okay, let's just select the bottom there. Try drawing on that. At least it's free and you didn't pay for some fucking mess left my ass out. You talking about solid work or what? Oh my god. Now the funny thing with this is it's not that always buggy. Suddenly buggy today. So V3CAD 1.0.0, the first release was solid. I designed an entire tool changer on it. Come on, alright, that's it. I know this is for... I know this counter is for the MissChanger project over there, but I'm gonna give it an extra one. Okay. Yeah, there we go. This is a bug that is just like, this is weird. Oh my god. You'd like to build 3D printer, maybe a Voron or something, some tool changer, maybe to assist some support material. Yeah, good luck. There's a lot of choice out there, and yeah. Okay, what is going on? Alright, that's first of all, I don't need that. Second of all, I don't need that. Third of all, let's just try this. Okay, that look promising. 9, 20. Oh, wait. I think I understand now. I think I have to zoom in. I make a lot of sense now. Okay. Remember what I was complaining about when it come to the thing just doesn't scale to where no. So the whole bug there, I think it wasn't a bug. It's just okay. And I have to take the bug count now. It's not a bug. It's perspective, right? The software were operating in a more zoom in view than I thought it was. So 20. So I put that at 20 millimeter there, but it was zoom into like a nanometer size. So it was like, so I thought for sure that it is that is just broken. But no. Okay. Then why this button didn't work? Whatever. Actually, I'm gonna keep it 7 there because the button, I did click this view all button. It didn't show me the right button. All right, how big do we want the wheels? How big do we want the wheels? Let me grab the prototype I have over somewhere. Where is my prototype? I swear I haven't threw it out yet. Uh-oh. Where did I put my prototypes? Hold it. That is PDG. Uh-oh. It's been a year. It's been a year since I last cut this, so... Oh no. Crap. Alright, this stuff under that pile there somewhere. Yeah, you guys just have to keep seeing on top of the corner there. I think it would be cool to build my own 3D printer, but I know it would be a challenge. You'll be surprised how easy it is. Oh, well, unless you have to design it. Wait, no. Even if you have to design it, it's quite easy. There's a lot of components. It's already open source and it's already very well thought out. So the Clipper firmware, for example, it's a firmware that open source printer use. Oh, and there's some others alternative for it as well. There's all thought out or planned. Oh, there we go. Found it. Wait, no, is that not it? What was this? Yeah, so they're all well thought out already. So all you need to do is just figure out what orientation of the motors you want. Yeah. Oh, where's this? Oh, god damn it. Why is it flipped? Ah, there we go. Yeah, you just need to figure out the orientation of the of your part, of how you want to mount the motors and all of that, and what you want to make the gantry out of. Challenge nowadays not to make the design something, is to document it. Like what I am doing, for example. Like for me, for my two-changer project over here, I'm already done on a personal level. I know where everything fit and everything works. Challenge is not that. The challenge is to write it all down so that other people can do it too. And I think I have threw it out. God damn it. I threw it out. Alright. We're eyeballing it. Oh, so that first layer is a little bit yeah, cam backward. Yeah, I don't even know that. I didn't know that was a real thing. Oh no, that compatibility. What is it? The hard part is making everything compatible for all of the open source part and stuff. Not really. No, it's once again, it's about how big you want your keep your project, right? So I know because I talked to the lad who designed the some of the open source toolhead, and there will be a lot of requests. If you have a popular project, there will be a lot of requests. Are you bet Voron 230 volt? Yes, it's on AC 230 volt. What is it? No. So when you make a popular project, there will be a lot of requests like, can you work with this? Can you make it compatible with this? Can you make it compatible with that? And fair enough, that's what people want. But if you draw a line early on and just tell and make sure that and stick to that line, i.e., like I will support this thing here, and the best way to do that is just to say I will do all of this because. For me, for example, I built my two-changer, and I just say, and to be compatible with a list, there's a list of compatibility on it, and I will not move and I will not deviate from it because I don't have money to do it. Just don't. Where is this? Oh wait, no, not cancel. There's no extrude just so I can see what I'm looking at. There we go. Once again, this thing, for some reason, love to just go inward. Alright, I need to be this in two direction. Symmetrical. How wide do we want the wheel? This is the now. The way these wheels are designed are, well, very interesting. So, oh, not random color. Okay, random color. Sorry. No, so the way that wheels are designed, and this is for normal wheels. And I would like to make it something just for myself, not to publish. It's hard to document and make everything polished enough to release to the public. Yeah. You know. Huh? Yeah, if you want make a one-off for yourself and just for yourself, it's actually pretty easy. Oh, I need to do something really quick on this laptop here. I need to draw on. I need to make a note on what I'm up to. Better not show you. Need to make sure that I'm not sharing anything incriminating. There's nothing wrong with making a personal project and then brag about it online, is what I'm trying to say with the idea. You don't have, under the banner of open source, right? There are there's a spectrum of projects. There are personal projects that just happen to be free, that just happen to be available. That is so imagine yourself doing a car mod on in front in the front of your house, right? For example, you're doing like a little modification to your car in front of your house. Everyone can see it. Everyone can appreciate it. You're not obligated to help anyone to do the same thing. And then that is one end of it. The other end is a collaborative one, where it is where you are to be expected to provide documentation. You need to help people to do the same thing. The peak of all of that latter part is the latter kind is the Linux project, right? No one know Linux inside out, simply because it's not. Oh, the mechanism board. Let's open that one. No one can. Now for that one is sometimes they have you took money as well for it. At which point that you have to commit to what you do. You have to commit to what you do. I personally am not took that much money from my project. All right, so right. Wheel design. Let's go to the tablet view now. There we go. Yeah. So let's talk about wheel design. Wheels are a very useful function. Oops. Wheel design. Wheel is a very interesting thing. Interesting object. Look very simple, just a circle. But over the years, people have found ways to optimize it. Basically, so if you look at the car wheel, for example, from the side, right, from the straight up perpendicular to it, you see a rectangle like that. The reason why that is the case because they want as much contact area as possible, top and bottom, like that. That way to keep the car gripped on the road and flowing. Yeah, no, yeah, okay. Yeah, so the idea is that the car wheels are designed with these flat bit there, so that it can grip on the road as much as possible, as much surface contact as possible. Because the car, well, it's 2 tons, 500 to 500 kilo to like 2 tons vehicle. You need it to be grip on the road. That had to be like that. On a motorcycle, on the other hand, if you look at the side, it's an oblong shape. No, it's something like that, right? It's something like that. Trying to make it look good, something like that. Yeah, with the flat left hand side. But more importantly, this part is curvy. The reason for this one specifically is because this need to account for the steering of it. Right, it's leaning is one of a very key part to the steering of a motorcycle or a bike. So that curvature here sacrifice surface grip that you would otherwise have on the car for steering, for handling. So why this matter? Because right now I need to make a decision. I need to make a decision of whether I need to go with this one or that one. They have their own challenges. And honestly, I don't think I can have a choice here. I'll show you why in a minute. But yeah, I don't. But ultimately, I'm on a skateboard, right? A skateboard. Yeah, the skateboard has 4 wheels. Skateboard has 4 wheels on the side like that. So I don't need this. I don't need this. I don't need that one. I don't need the skateboard wheel to be like a bike tire. I don't need to lean on. Because there are 4 of them, not 2 in line. So I want it to be as close to the car wheel as possible. So that's the idea. That's not going to be easy to achieve. Right? So how do we do this? Dun, dun, dun. So with that, yeah, I just talked myself into it. But yeah, we'll go in with the flat wheel. That's why we're going to with the flat face here, as flat as possible at least. Oh, the other thing that I need to consider, we keep in mind, is that we need to keep this circumference as circular as possible. Not gonna be that easy. But that is something to keep in mind. So I'll keep that body as the outline, wheel outline. Wheel. Oh, come on. L. Outline. Okay, so what I will now do, one now is the another part. I call it the axle. Axle, roller axle. Roller axle. Roller axle. This time I shall also expose that, hide that away. Now I'm gonna grab, oops, that, put it on a this random plane, and then spin it around the Y for 45. 5. So it. Draw me a hole. Dimensionally 5 mil. Right. I don't need to define it just yet because I don't know what I'm doing myself right now. So let's extrude it first. Both sides. Symmetrical. Give it 100. And then bring the other wheel back on. Now, first of all, you can tell that this is not true. No, so this pin here is what the roller gonna spin around, right? And immediately you can tell. So for that to happen, for the roller to be able to spin around this, there need to be enough space on top and bottom. No, outer and inner, and when in relative to the outline here. So I need to move this pin upward near the edge here. For 1. 2, actually what I'm gonna do is in here, that one I'm gonna pull this one in as a reference, so I can hide it for 1. But more importantly, I can hide that stuff for now. There, draw another surface here, random plane. And then I'm gonna negative 45. Come on. Number. Negative 45. Okay. Draw on that. But that way. And what I want with this is I want to take that. Oh, I want to expose that again. And I'll need to trace the circumference of this one. Oh, how this gonna look. Alright, this is the new feature that I wanted to test now. There we go. Aha. Used to be not, no, so this is, so you can either have a projection, like a 90-degree projection of the whatever you select, or you can have an intersection. So if you have 2 planes intersect with each other, that's this, which is what this is. It will give you that. The projection won't work here because the projection of because the 2 plane is what it's called is intersect, they cross each other. So the projection, I don't know how to explain it. if I go here, for example, and click on that, for example, yeah, you can see that the projection looked like that. It looked like this oblong looking shape here, which is not what I want. Back to projection again. Yeah, you see? If I do a projection, it looks like this oblong shape here. It doesn't mean anything for me. I need the intersection that face, which is just that, and that underneath, that's there. And I need to be able to rotate that around this pin here. And to do that, this pin need to be in the middle of this and that. So it has to be at least halfway through this wheel. So this wheel right now, let me check again, close that, is, oh please, 100. So this pin need to go up. Let's say dimensionally, there we go. 50? At least 50. Oh, what? Oh, wait, no, sorry. 25. Halfway between halfway. So a quarter. 24, 25, so make it 30 because I do need a pin in the middle. Yeah, like that. On this sketch here, and grab that. Hide this. I need the center of this pin. So let's grab this end and this end here. Do a cutaway so that, yeah, there we go. There's a line right there. No, let's just hide this object here. Oh wait. Alright, sir. Alright. So let's put it back on really quick because it was in the section that I used, which is not working on this one specifically. This one I need a projection, which showed up as a line instead of a 4 point that connect the two planes. Grab a line, another line here. That center point to center point, and I need a shape that mirror this, but on this side. No, I don't. Wait, I don't even need this, do I? Yeah, we'll deal with that later. Okay, let's just draw a shape here. There. Oop, and there. This one over constraint, get rid of that. That one is vertical. And that one is now, just turn it to a normal line instead of a construction. There we go. So I can take that and spin it. Where's the spin? No, sorry. That one. There we go. Vertical to sketch the select reference. Now can I just select? Damn it. Okay. There we go. That's fine. Outside. Right. So that was I don't know. I looked my problem, but the stream is buffering like crazy. Oh my god. Let me check. Wait, no. What? What? Oh god. Could be me. It could be me. Network. My network is, oh, I'm sending 12 megabytes per second. A lot of megabytes. Oh. No, it's buffering for me as well on Twitch. I can still hear myself though. Oh wait, no, Twitch is fine. Maybe YouTube? Let me check YouTube. Yeah, no, I'm dual streaming right now because my landlord upgraded the internet recently to like a gigabit internet on both up and down. So I was like, oh, I want to test it. Oh, it's better now. Okay. All right. Yeah. So I'm a little like what's it called? jumpy when it comes to internet speed because I'm dual streaming right now, and as you can see on the screen right now, yeah, the network I'm sending like 12 megabit per second consistently to the network. not exactly a low. It's not bad. It's not bad. Like I have for 12 megabit upload. Not bad. Not like It's not like I'm hammering it so hard that I speak gonna go crazy about it. But it is enough that it may not be the cause of a problem. Anyway. Right, so I need to bring back the old wheel here. And immediately here you found a problem to be solved. But you see right there, because yes, the projection allow me to mark this line down. But you can see right there, that line can be marked down precisely. But the moment you rotate it, this part of the roller started exposed, right, on both sides. And while this other end here, I have gigabit down as well. But sometimes Firefox kill YouTube RAM because it's got RAM leak. I didn't know that. Probably why I shouldn't. That may or may not be part of the reason why I am using a 15 gigabyte out of my 16 gigabyte of RAM right now. Oh my god. God damn it. Yeah, I was complaining on stream. Been complaining for a few days now that I may or may not need more RAM. But anyway, before I do that, I need to thought things through for a sec. 16 is it's so little nowadays. Dude, it just 5 years ago, it was perfectly fine. It was the norm. And nowadays, you can't even increase if you wanted to. It's like 200 pounds for a 32 gig DDR4. And even more so if you do it on DDR5. Ain't nobody got that kind of money. And how do we deal with this? So this is the problem with mechanism wheel, right? You need to simulate perfectly round wheel with an angled roller. So clearly doing a perfect projection is impossible. That's what I was saying. What I was saying about the why I was talking about the curvature thing, projection and intersection thing. Doesn't work one-to-one. So what I have to do now is that not instead of this, I need to make a deeper curve. And I utilize 25 gigs somehow. I don't even get it. And yeah, RAM is so expensive now. What the hell do you do with 45? Oh wait, you may or may not do 3D CAD stuff, huh? Yeah, CAD stuff. CADing. Oh, wait. I just realized something. Wait. What if I look for both? One sec. Take that. Yeah. Turn it into normal. You see this little yellow bit on top and below, on top of the purple line here. That's the part that poked out. That's the part that poked out. That's the part that poked out if I rotate this yellow line, that's orange line around. So, and I just we can see it, right? We can see it here. So can we not draw something? Let's just grab the projection down as well. A little messy, but projection down. So because of the intersection, because of the angle of this, if you rotate this or this line here, that line there, if you rotate it the whole way through, it's gonna pull down a little bit on that side and that side right there. So I'm trying to think here, is there a way I can... Oh man, honestly, we handle this intersection forward. So let's just draw a little thing. Let's just draw, because I'm running low on ideas, so I'm just like keep drawing for a little bit. See what I have. Okay, so let's use the curve tool. There we go. One, two, three. Look weird. Okay, these two should be equal. Should they? Yeah, they should. Should be equal. This one is already in the center, right? Good. These two ought to be symmetrical here. That I can control the shape of this. It looked like ass. Yes. But it worked. I can just pull this up really quick. Take that point. Intersect that with this one. Connect that. Barely see what I'm doing. Face. So, oh wait. Let me connect that to that really quick. That to that. Like so. Same over here. Wait. Alright, yeah, no. Okay, that to that. And what if I drop this? Just like that. Give it a straight line. Okay. What that look like? Do you think? Okay. Oh no, so the point itself, the tip itself also curves slightly. Need to be curved out. This is yeah, I was yeah, way that I did it before, the way that I did it in the overs, and then I just moved the axis here closer to that pin, because as long as the radius of this circumference here, of the cross section here, is small, that little protrusion here is actually very flexible. But once again, the problem with that, the way of designing, is that now the thickness of your tire is minuscule. So I want to just start with the pin where it's and then trying to figure out how am I gonna counteract the forces of nature here. And clearly, the first thing that need to be recognized is that these 2 points do not meet it there. They not meet there. Yeah. So they did not meet there. That's for sure. I do want this to meet it here though. Connect that. So let's see. Right, just do that really quick. Okay. That. So I'm just trying to move things around, see what is the best way to do this. So I'm thinking I may not have the choice of going with a flat tire after all. I don't think I do have that choice. But I do want to make sure that this is the circumference here is somewhat close, please. What I should done, therefore, right? So no, so there's no choice for me when it comes to having a perfectly flat tire, the optimal shape. I won't have that. I don't think that is not in a book. But I can try with if I can see it. Alright, there we go. I'll grab it again. Yeah. What I can try is to have a section in the middle as close as possible to it. So what I'm gonna do, curvy part again. Grab that. So I said between these three. Okay, let's just draw it out before I go and commit to it. Yeah, so I add an extra point there, 2 point there. Add an extra 2 point there, so that we have something to work with. I'll grab that. Oh no, that one. Oh, sorry. Yeah, that one. That's the point. Need to be there. Connect to there. Oh, we're gone. Oh god, what did I just do? Okay, let's just move it to the left here. There we go. Alright, and that one also need to go there. Like so. Okay. And since I guess this one also need to go there. And so is oh yeah, and that one that one need to be symmetrical with that. Okay, so it's that guy, uh-oh, that okay, symmetrical constraint is too much for this, so I'm just gonna make it horizontal. Itself gonna make it symmetrical, not wood. You can see that the middle section there is track the middle section there. No, this section here in the middle track along that line much better. I may or may not have to increase this slightly. Back. Now let's just leave it at that. We'll just test it like that, so that will keep the end of the wheel to be the exact same length. That. Okay, so now let's see what the revolute look like. Right, so the middle bit here, you see a little bit closer. So now we can adjust this slowly. Wait. Just pull it down inward a little bit. Yeah. Okay, this. So I want the bottom to go up slightly, I think. Yeah, I want this edge right over here, touch that. So, radio. I swear someone somewhere should might have already figured this out. Like there's a mathematical equation where they can just design this, right? But I haven't seen anyone do that. I haven't seen any paper of that sort, so I don't know. Okay, like that. Too much. That's too much. Put that tip down slightly. Shouldn't be just helical line. No, so I don't actually. I'm not too sure what once again, not my first language. I don't know what you mean by helical line, but no. So if this, yeah. So because of this thing is it's a 45-degree angle here. Because of this 45. Oh. Because of this thing is it's the roller is 40 at a 45-degree angle. What is perfectly track this line here? If this line perfectly match with the outer shell here, when it's rotated, in a what is it called? Sweep, the revolute, the corner over here would then be protruded outwards quite substantially, and the one on the left of it, this side, would not be. So you can't just project this surface into the plane and then rotate it. No. So what I'm thinking is maybe not what I want is not the what I want is not this line here, not this black line that you see here. That's the plane of which I am doing the revolution. What I don't want, I don't need that line to be what's the right word? To be to meet up to the surface here, this curved surface on the outside of the wheel here. I want the line that is slightly offset to it right there, lined up. I don't know how to do it in CAD. That's the key. I don't know how that is calculated, nor know how to do it in CAD. But what I can do is just to trial and error it slightly and just get it as close as possible. Yeah, you would want a 45 arc on a cylindrical surface. -45-degree arc on a cylindrical surface. Yeah. 45-degree arc on a cylindrical surface. Can you put a plane through the middle of the cylinder at a 45-degree angle? Middle. Wait, what? Like that one? No, there's that thing there. You may not see it there. That one, and then a 45 arc. Yeah, the intersect would shape the wheel. Degree angle. Can you put a plane through the middle of the cylinder? No, because I'm reading your comment right now. You may have, because I'm taking ideas in. So 45-degree arc on a cylindrical surface. Okay. The intersection will be the shape of the wheel. The other way. Oh, the other way. This one? Oh yeah, you mean this one. No, that one. That one is perpendicular to that wheel. The one that you're talking about is this guy. Yeah, that surface there. The green one in the middle. Yeah, so if I do that, yeah, so that's what I'm doing here, basically. So I'll take that surface, and then I project the arc of this circumference down. No, that's yeah. So yeah, that's what I did before. Yeah. No, it's not that simple, unfortunately. Once again, if I rotate that, yeah. So if I have a intersection projection of this arc here. Let me hide this one. Oh god, this one is actually really difficult to show now. Oh yeah, never mind. Come on. Yeah, you see that orange line here? That's the projection of the arc at a 45-degree angle you were talking about. Unfortunately, it doesn't work because that projection means it drew up this line here. Let me just hide that. So close that. Yeah, what that projection show is the projection of this line here. Hello. That projection showed is the projection of this line here. If you were to have it touch the arc of the wheel the whole way through, the problem with rotating that wheel when it rotates on this axle through on this plane here, if you rotate that line here on the lane here, you see this left part, the right part protrude outward. Why did you even switch to Pop OS? I like this part of it. I like the part where I can navigate. I can do the what's it? Can do all this sizing and all of that. For one, and for two, it's based on Ubuntu. Fedora is nice, when you first install it, but then you trying to what it called update it every week, and at first it's just the what is called the symbol UI on your first login that fail, and then your app start crashing some randomly. It update too quickly basically for me. Update too quickly. So I want to go back to a Ubuntu based system, so that I just like you can break or you want. I know. I mean, hey, progress, right? We cannot sit on the same thing forever. So I'm happy for you to break your system only once a year, in April. That's why I'm going back to Ubuntu based system. And specifically for pop, it's because well, for me specifically, because yeah, once again I like the tiling window stuff. Just love that. The new system is a little annoying though, right now, with all the whole you know, rebuilding of the entire OS and all. So where was I saying this? Is this Wayland or is it Cosmic? Wayland and Cosmic is two very different things. Wayland is a display protocol, and Cosmic is just the desktop environment. No, it's the yeah, desktop environment. So yeah, this thing is on Wayland. Cosmic Wayland. So system about, there we go. Yes, you see, OS 24.4, Cosmic and Wayland. So yeah, Wayland is display protocol, and desktop, the DE is how it looked and feel. Cosmic for that matter, for you may matter what may you may been asking what is that Cosmic is very new. It's built on Wayland, fully on Wayland, so there's no x86 support. What was that in desktop environment that does tiling? There is Hyperland, i3D, i3. All of that's basically is that. None of that is good. They all announced, honestly, as far as I'm concerned, it doesn't move all that much. Right. Oh. Yeah, what's that? Yeah, Hyperland. I wanna say no. It's Cosmic. As much as I like filing, I do need the system to do like normal Windows stuff sometimes. So the best example, no, the best use case for the normal window, no matter on which system you're on, is Steam. Steam is a how to say this? They have not bothered updating it in, and you see right now, it's running on x86 emulator right now, and that's a good thing because that means so for Pop OS just go, all right, you see Steam, you don't tile it, because this app they will only update it whenever there's competition in the market. And the last time Steam ever felt enough pressure to update their app is when what it called Epic Game Store came out. That was like 6 years ago, and before that it's like 10 years of nothing at all. So even now, even to this day, this app is still 32-bit window. So yeah, so Steam is one of the prime example why you don't want to go full tiling like with Hyperland, because it's not gonna scale well. It has a popped up over and all of that, which is why it break everything. Oh, actually, I can show you how it break actually. So if I go to a where is friend list? Yeah, see, the friend list popped up with tiling just fine. Main window doesn't work like that. And you can see, and the pop-up element is the worst thing to happen. No, the enemy of tiling windows is pop-up windows, right? So like imagine your if you're on Windows on the Windows OS, imagine like a random popped up like a warning window, right? Just and that little popped up in a tiling manager system, you're gonna just occur. It's gonna take up half the space of your width of screen randomly. So for PopOS, the reason why it is I'm giving it more slack than I need to, because for example on PopOS the way that I work around it is that instead of having a pop-up window for your notification, or for example in this case it would be to show the detail of the app, right? So if this is on GNOME or KDE, this detail window here would be a pop-up window, but no, but on PopOS they put it into the app itself. That way that way it will work better for tiling. And so for me, I look at that and I go like, that's good design for me, because for me who like tiling, that's why I'm trying to support them. I donate $5 to them every month for this. Yeah, I'm not regretting my decision of the support, but I am regretting my decision of I'm not regretting. I just re-evaluated my decision with this idea of running this right now, because technically you're supposed no. The release was not good. Let's just call a spade there. The release of PopOS was too immature. This alpha software, no, it's alpha software that they release is beta software right now. They should have waited until the at least 2604 came out with whatever new stuff they're coming up in a month's time before releasing PopOS. Yeah, no, KDE is great. I'm not arguing with that. It's right now if you go into Linux, select a distro with KDE. No two way around it. No, not just the look and feel, right? It's not just the look and feel, it's also the performance. KDE performance, I don't know, I saw a YouTube video about it, but recently someone tested it and KDE performed way better than GNOME or PopOS. PopOS is not even in the list because it's still it's once again beta software. It's bloated, it's buggy, a whole sort of problem. KDE is performed noticeably better than every other competition it have right now. So yeah, that the only yeah my okay, I need more points on this. Okay. Yeah, so my reason, well, the only reason why I haven't used I have not used KDE. No, the one weakness of KDE is that there's no desktop environment that just there's no I should put this. There's no distro that with KDE that I want to use. Let's call it that. The only I was hoping that I can use Fedora KDE. That's my main. I swapped to it for a while, for a few months, but I was really hoping that that one would be it for a while, but no, don't like Fedora. So I had to go away from it. Ubuntu had Kubuntu, which is a decent system. I'm still thinking of swapping to it, but yeah, but have not made the decision yet. Still have a hard time parting way with my tiling window manager. Connect that. Okay. Oh, it was it. Once you get used to GNOME and all of that, having the tiling plugin for KDE, but I don't know it's good. No, it's not good. I tried. OS had been in a bit of a difficult place for like a year now. Wait, no, 6 months. Wait, no, 8 months. So over that past 8 months, I've been trying my best to get tiling on GNOME, KDE, and all that, and none of them work. ultimately it once again came down to the fact that it need to be designed for it. Right? You can't just slap tiling window on something and hope that and then expect it to just work. It had to be designed. What am I looking at here? A second, I need to think about this. It has to be designed for it. Alright. Oh boy. Yeah, I just want to ask. Yeah, no, it's fine. Honestly, the title is there to bait you in for some comments. The fact that you're here and giving me some comments, that's pretty good. It was there. Thank you for popping in. And I need the left and right to be symmetrical. How do I do that? Get this one and that one be symmetrical. What happened? Middle line, okay, that's fine. Why is this shape still not where it's supposed to be? Oh, because there's an extra. Right. Delete that. And restart. God damn it. They just have to give me another one. First of all, let's just hide this. It's so cluttered that I cannot tell what I'm looking at. Alright, 1, 2, 3. Five, 6, 3, 3, 1, right? And 1 there. That. Then I'm just gonna grab these two. That's symmetrical. That one. Oh. That one. And that one symmetrical as well. The funny thing about Linux is how much lag there is for the people in it. No. So how much was it lag there is between those who follow it religiously? Me, those like a normal person who just like want to hear about it once or twice a year. Linus Tactics, for example, is the one person I'm thinking about right now. He run it's like every time he run on trying to do a Linux challenge, he's always end up with like outdated information. Can't blame him. It's changing so quickly, so often. But like it's all but like this is not the right time was it recommend pop oil. It's just not. One sec, I'm trying to keep focus on a sec. Alright, there's this curve going down with this weird bump going up. Interesting. Alright, put the binder back on. Yeah, so instead of tracking the line, trying to have this line being perfectly matched, I'm trying to do I don't know how to get this one done, but there need to be another one right there. What is that point? I'm trying to think here. Because what I'm doing right now is very hacky. Right? It's not mathematically correct or structurally correct. It's like I just like tweak it until it fit. I'm trying to think here. I need to be able to find 3D position of that of that ship. We try to sketch really quick. Close that. I need to be able to find the mathematical position of that lump on the top there. Right? Because that lump there, that little rolling outward here, when you rotate it 45 degrees, it ends up there, where the wheel is poking out slightly. Trying to think. If I then, instead of drawing on that line, I should draw on this line instead? No. Trying to think. Okay, let's try something else. Painting this on is not impossible, you can tell, but I don't think that's a good idea. Yes. Let's grab. Go back to this idea now. Why is it popping now? That's sketchy. Let's not dismiss this shape just yet. Alright, so we need to know the apex here, this distance here. Should I say we need to know and go here. And we can quantify this. God. Where my throat is killing me. Is that a halfway point, maybe? Oh wait. Grab that. Yeah. And draw on it. We will project this one down, like so. It looks weird. This distance here is the one that we're looking for. Hell yeah. Okay, so cut away. We want to be, how do we do this? Oh crap. Wait a minute. Okay, start from that point there. So, oh wait, no. So the way to do this is to grab that hole there. Yeah, grab that center point. Draw a circle there. That is my first point. Okay. Okay. Stick with me here. Circle. Okay. Yeah. We can do this. That is first circumference that we want to chase. Oh wait, no. That one is dimension. That's the first one. Oh, it is divided by these parabolic shape here. Oh. So a circle project a parabolic shape on at a 45-degree angle, which is that. So we need to trace the from the same point there, circumference of all the section here. Because ultimately this is the one that we want, or for it to perfectly match the shape of this tire. Right, so we need to trim that down. Do that. Okay, do we then create a center one? Then a one before that? Hold up, close that. What do we want to do? It's not this. We don't want this one to go back here, because this is definitely wrong. We don't. Oh, sorry, that is definitely wrong. Okay, that's definitely wrong. So we don't need it as a proper line. Get rid of these two. What we want is just a reference point, right? A cylinder, so that we can shape away to the shape until we got the shape that we want. Grab these, right? So, why is my throat feel scratchy? Like so. To give it a cylindrical shape first. Alright, close that. This one is still the same, yeah, because this is the circumference at the point that we for this one. Now we just need to go down this tube. Let's draw a bunch of lines. Close. I feel. Did you know? There's definitely a mathematical equation for this. There's definitely a mathematical equation for this. Don't know what it is. Fortunately, I know it has to exist. I know it. And what I'm doing right now is just guesswork, right? Guesswork and estimation. We got that one. Okay, what's that? So that one is there. How long is this? 70. Make it. All right, we extrude it to where it gone? No, we don't even want it to be that specific. Okay. Oh, get out. What? Get out. So yeah, this length is 70 something, but we don't even need that. We don't need it to meet these two either. And they are now mostly just there. It's just mostly there for show at this point. I want the diameter here. Give it 74. 74. Yeah. How much is 74? Oh, the tires. Wait. Might be too big. I did this once before. It's just like huge. 74 is about a thumb word. Around that much. Yeah. So about that much. 74. Not bad. It's still quite big. Not bad. Maybe put that down to 60 actually. We may come to regret that decision at some point, but for now, we'll keep it at that. And I need to put a dot here. Make that actually. What's this one? I don't know. Click that dot. Come on. Selecting a dot in this app is difficult. Like that. Tension. There we go. Okay. Right. So we need a surface halfway down, so 30. No, let's make it quarter, 15. Minus 15. Okay. Look at the 15. I'll draw on it. Like that for now. Oh, let's just show it. That's just fine. Draw on this. Just like the other one, we shall grab this surface here. Oh, but the weight hurts. And that hole there. There, come on. Where aren't you working? Okay, wait. Don't cut away. That one. Yep. Now it should work? No? Yeah, I have no word to describe this parabolic looking shape. I know there should be some word, but I don't know what. And it's not, oh god, it's not, stop working. Why is it not working? Hello? Why don't we grab this sketch here? Should work, right? Oh, it didn't work. Pick geometry, I did. Free cat, what are you doing? I swear it was not this buggy literally yesterday. Why can't it work now? Axis. Why won't it work now? Come on. Wait, maybe in section. Yes. There we go. I used wrong. That makes sense. That wasn't it's not buggy, it's just me. Oh, and now I need a circle. Center. And tangent to that. Why did the tangent fail? No, doesn't matter. Let's do that. Close it. There, that's the way. So let's just let's put this into a toggle panel. Yeah, so we're drawing this. I think it's time making sense now. We're drawing the sketch. Oh, a skateboard. I want to make a skateboard using these wheels. 3D printed wheels. The what is it? I don't know if you guys know this, but in the UK, this is technically illegal. Electric skateboard are technically illegal because they're afraid them getting on cut. They were afraid of it getting caught on fire on a train, and or people running like an idiot in a park, 30 miles on a walkway, mile per hour on a walkway. But nevertheless, the government had they've been kicking the can down the road for like a few years now. But they are meant to revise the law to find some form of acceptance for the electric skateboard later this May. By later I mean like next week. Yeah, it's all down to it's all down to public transport, isn't it? Because if one of those things get one of those unknown batteries start getting caught on fire inside a tube, you basically got a fire hazard. For one, you may burn down the tube, the train itself. But for two, those are the fume is not exactly safe. So you're basically closing down the entire system for one idiot buying buying a cheap unknown battery. So I totally agree with the idea of not letting them in unless you know what you're doing. The only reason why I am a little frustrated right now because the British government had been kicking the can down the road for years now. That's why I'm just like, you guys need to make a decision eventually. Oh, lithium fire are no joke. Yeah, like just recently, some the annoying thing is even well-made battery, right? If they are not well maintained, can caught on fire. So like just recently, some old lady in America just had on. No, it's not. This is not an electric skateboard, but she had a lithium battery powered wheelchair. But she's old. No, not wheelchair. Sorry. Mobility scooter. Right, one of those legally protected thing. She got one of those. She bought it secondhand, and when she got home, it stopped popping. And she heard a pop, so she rolled it outside. Just as she did, it's exploded literally on her front yard, like boom. So even well produced battery, if they were treated incorrectly, they can caught on fire. So we need to get those on the street. You need a lot of work in terms of like organizing and government like what is it? Government. Oh my God, what's the right word? There's a lot of effort in terms of regulation to keep those things safe on the street. And unfortunately, right now, given the whole world in flux with other things, that government effort is just like on hold for years now across the world. Very unfortunate because as much as I like electric car, like seriously, I would not buy a car that is not electric. But as much as I like that, I do not. That it's better than combustion engine cars, right? It's better than that. It's more reliable. It's cheaper to run. But it is only the second worst. Right? It's the very worst thing for mobility. It's like it's rolling a 2-ton metal box around in the normal diesel engine. The second worst is electric vehicle, and on top of that, so the best way to do it is actually just to walk. If you cannot walk, go cycle. If you cannot cycle, get a train, and then those two, right? So you can get away from the rolling a metal box around. Is the better. The further away from it, the better. So yeah, so I was what I'm saying. The idea is I want electric I want electric skateboards or scooter be legal, safely legal, not the just recklessly legal, but safely legal. Grab that. Oh, this one there. This is the one that we were referencing. We said all of that, but then because the funny thing is, the people who impacted the most right now are the people who are most likely to be moving to electric vehicle and all of that attention, right? So the only thing that is the only penalties that they have for the folks who use electric scooter right now is deduction on driving license points. Okay, so if you are someone who don't see yourself using an electric using a car at all. That basically that is a non-issue. So a lot of people, especially kids, a lot of kids running around, they just buy the most powerful electric scooter they have, they can get their money on, they're willing to spend on, and they was throwing themselves on the sidewalk at 30 miles per hour. Like I said, it's ludicrous. And running at car speed with something that is less safe than a bike. It was needless to say, I was infuriated. Unfortunately, not like we can do anything about it. But you know. Okay, alright, let's hide that. Alright, see, now we got these lined. So, what I will do is that I need to grab that line. Oh, is that section? No, I will projection. Yeah, I need the lines. 3. So let's see if 3 works. Oh wait, no, not like that. Damn it. Ah. What? What did I just do? Okay, let's do that again. Dun, dun, dun. Grab one, that one, yeah. So we draw on that surface and then a plane there. Grab these 3 lines. Okay, I'm gonna learn from my mistake here and not connect the point right at the beginning. Just gonna put it there, there, and that there. Right? I'm do. So I take that and that, make this symmetrical through the center. So it's these 2, I suppose. Oh, and that one can also go in the center. That. Okay. That one can go connect to that. That one connect to that. Ooh, this. Alright, this need to I'm over constraining something. Oh wait, no, it's not. It just one didn't work the first time. Okay, this is not perfect. As you can see, I can still change quite a lot, so the shape of this thing can still vary. Not much at all. I reckon we just keep it there right now. This one, yeah, this one. Hide these now. What the hell was that? When you have a 3D printer, sometimes it do one of these travel moves across the bed, and it go like grrr, and it go like give me a jump scare there. Okay, down. Oh. Well, don't need this one. Okay, so now can I? Oh wait, no. Rosette. Wrong way, because we already had a shape. So this is supposed to go upward. This is a cutout, not a rotation. Not a protrusion. I don't know what the right word for it. It's something. Yeah, let's just give it 30. Look good. Okay, so this guy, let's bring back the revolute here. Have that. Wanna cut it. And around. Oh, why is it not working? Cancel. Take that. And I say cut it. Around vertical axis. No. Select reference. Yeah, that one. Okay. Alright. Drum roll, please. Yeah. Yeah, no, because I had only used 3 points. So it does not perfect. It's not doesn't meet perfectly, but you can tell that it's so much more aligned to the shape now when compared with the other one. I'm happy with that. Happy with to go on with that. So what we can do now, and and the other thing that is noticeable about this one is that we can alter this. Don't need to delete the line and change it again at every point, right? So how we do that though? How do we do that? Can draw more lines. So instead of 3 points, I say I want 5 points. I don't know, 4. Yeah, so 30 divided by 4 is 7.5. Okay, so set this second random plane here. Yeah, set up 15. I say 7. 7.5. Okay, so just put a sketch that it's sketch on. Okay, let's make sure that the sketch cancel. Save. And yeah, the sketch to work. And we just put the sketches back on really quick so that it look so we know what we're looking at. Alright, so I'm gonna put another ring right there. So I'm gonna put another ring right there. So glass face again. On surface. I may not have to redraw that group thing, but we'll cross that bridge when we get there. So 7.5 times 2 is 15, right? It's 15, yeah, 15. 15. Okay, on that again, that one. Yeah, I may have to redo that entire groove. I draw on that. So once again, we grab the this is the projection. So check that one down for me. Then go to intersection here. Oh, I love that. I love that so much. Oh. This makes things so much easier now. Connect that, tension that. Got a board band there. Then we'll before we do anything else, let's just grab. Oops, save that first. Always save, especially now that my memory is. I don't know. The stream might go down in a little bit now. Soon. Oh my god. Oh my god, that's gonna be funny. Alright, make another one. Make another. Yeah, so 15 plus 7.5, so 7.5 times 3. 22.5. Two. 5. Okay. Grab that. Once again, draw on it. Another thing about these random planes, they don't hide themselves automatically. What are we on? So we are on the intersect right now. So let's just take the intersect first. No. In here. Oh what? Oh wait, no, it's not. It did not. Oh, there we go. There we go. Okay, so grab that. We go for another circle. Once again, I'm pretty sure if you do the math, someone out there have already done the math on this, and they'll have figured out that there's the perfect equation to match the circumference of this curve of this wheel to the circumference of this circle of this wheel of this yellow bit here. But what I'm doing is working, right? It's not dumb. It's not dumb if it's working. Okay, Okay. All right. So yeah, I have to delete this. This sketch is done after the fact, before this other one came to be. So I cannot use it. Close that because it doesn't see the one below it. Get rid of that. Yep. What? Uh-oh. I broke something. Random plane. Oh. Random plane, there go. Okay. Selecting. Okay. Uh-oh. What did I do? Crap, what did I do? That one? Yeah, that one. Ah, right. All right. So this may be an issue going into the future. What happened here is that there are two types of reference. There's the projection and then the intersection. What just happened there is that it messed up between the two. We don't know which one is which. To create this different shape that it's not meant to do. That sounds ominous because if in the future if I want to change something like I did before like this, then it may cause a problem. Yeah. Well, we'll cross that bridge when we get there. And to be fair, I don't think we're gonna change it once we settle down to an exact number or something like that. We're not gonna change it that much. I don't think. I'm not that interested in all of this often unless I have to. Right. So now we can grab this random plane. Oh no, this random plane here. No, random plane. Top one. Oh, not that top one. Where is it? That one. Yeah, that one. That. Again. Alright, this way. Okay. And then we draw. Oh. Fine, yeah. I'm purposely avoiding attaching it to anything right now. 3, 2, sorry, 3, 3, 3, 1, and then the fourth one, yeah. Grab that one and that one. Those are symmetrical. Yeah, so on these two. The line in the middle is green, so it doesn't show up at all which one I'm selected, and it didn't even take it. God damn it. Symmetrical. Oh, and won't you move? Come on. It's not moving. It's not taking it. Come on. Symmetrical. Ah. Okay. I hate that green look on it. Green is the color of the selector. There we go. So you cannot tell whether you had clicked on it or not when everything is green. Yeah, like that. It doesn't make any. It doesn't change color at all. So I don't know what's going on there. I know for a fact that these 2 points had been selected. All right. Go. Alright. Why don't I just select the one in the middle? Right, one more. Last one. Just make sure I don't select the point on the thing itself. Symmetrical. Right, that's it. This one is center. So, alright, that one's fine. Just stay where you are. That's it. 2 parallel section. Like that. Like that. Ooh my. That. Come down. Now that's the one in the middle. Okay. Is that it? It's weird in here is strange to me. It indicate how the I don't know what that they indicate, to be honest. Let's not kid myself. Trying to draw. Okay, give it a random dimension. And 20 is good. Okay, and how about this shape here? Are we happy with everything? Alright, let's close this first. Do the cut. Pin cut around. Select reference. Oh, okay. The sketches. And bring back the binder, please. Yeah, that is as perfect as I can get it, I think. Well, I can do more, obviously, but this is good. This is good. It is good. Oh, if I was young, I was busting out the pen and paper and figured out that relationship. But I'm good. I'm good. We're good. Let's just lock it in then. Yeah. Okay, just like that. Yep, that one. That. Why is it putting it? Oh, why is it putting it down here? That's my $1 million question. But, let's not. Let's not go into it. How big will the wheel be? Gonna finish wheel? 100 millimeter. 100 millimeter. I've been running around town basically, test out to see how many how big the bump around town is. The bigger the wheel, the easier for it to go through like rough terrain, right? But the bigger the wheel, the more material it is gonna take. So I am thinking about 100 millimeter. That's like in between too big and too small. I tried 92 mil wheel before, and to be fair, that's actually pretty close to what I want. But I just want to go like, hey, let's round it up to 100 and see what I got. So that is the wheel. Now, next one is I need to grab that really quick. I don't know. What I want to do now is I need to rotate it. I need to rotate this. How do I rotate it? I will need to rotate the whole thing actually. Okay, let's just grab that. Rotate it. Huh? What just happened? No, cancel. Grab that, yeah. Wait. Yeah, rotate it around the I want this to be the y-axis, yeah, like that. And I want how many? All right, yeah, this is why would that yellow orange? Okay, let's just say okay. Yeah, issue with mechanism wheel is loose gravel or small pebble of asphalt. Yeah, indeed, I'm really worried about that, honestly. That's gonna be make and break for this thing. That's why I'm thinking. That's why I'm. Oh, I was trying to buy a skateboard just mount it onto it and then run with it and see how that go. But unfortunately, the skateboard seller that I was ordering my deck from, it was a scammer on Amazon, and they took my money, 60 quid of it, and just ran. Yeah, the binding issue is gonna be an interesting one. May not be that big of an issue, to be honest. Not the biggest issue, is what I'm trying to say. So the bigger issue in my mind right now is if you take this wheel right now. No, so right, just take this. The circumference of yeah. So there will be there is a minimum circumference on the hub on the both side here to be able to hold on to this rod in the middle. No, I did not get a refund. So the way that they did it, and this is probably a good good learning lesson for everyone, in case everyone listening. So the way that the scammer work is that they're gonna give you a long drawn out wait time, right? They're just gonna say they're gonna come up with some the one that scammed me. The way that they did it is that they just like said they just wrote on the sale page that, hey, we actually, this is what's it, artisan bamboo deck, right? You're gonna take 6 months to get there. And I didn't notice at the time, but apparently after 6 months, Amazon just like, it's no longer our issue. It's between you and the seller now. And that is the point where the manufacturer either they kick the can back down the road further and further and further. The longer they can get you to, they can convince you that to wait, the less money that you can get back from Amazon when you file for a refund. So yeah, so if you go and buy anything from Amazon from now on, because let's be real now, the system is getting worse and worse because people are finding ways to gain it. So if you are on Amazon trying to buy something, if they promise you mention a long wait time, delivery time, be skeptical. And if they hit the first, if they miss the first delivery, just cancel it. Just cancel it, get your money back, and then figure something else out later. You cannot trust it anymore. Anyway, with this now, some of the mechanism wheel, the problem is not just the pebble getting locked into the wheels, right? Because if the pebble lock itself into the roller, the wheel is just gonna roll as a normal wheel. I'm not doing crab walk all the way through in my entire commute. Crab walk to me is just a feature on top of the feature. So so for the most part, I want this thing to function like a normal wheel. So for me, being stuck, these roller getting stuck is not a problem. The problem is the fact that you see how this the circumference of this bigger wheel here. You can see how the rod is the longer the rod is, the holding rod is, the more closer to it is to the circumference here. What that means is the tire, that is to say the rounded bit that we just made, we don't have that much tire on this thing to grip on the road. So if this thing gonna wear down very quickly. That's the main concern for me, at least with the older version of this, where it just didn't work. All right. Now you wouldn't believe this. Okay, let me just try this again. Why is it this? All right, let's just revolute this now. All right, let's do it. Let's just hide this. Put the where gone? The binder on. Yeah. Base Y actually. Actually, I don't need the binder. Okay. So now, and the other problem with the design right now is how will they interact with each other, right? So if I go from the side here, is this a side? Yeah, this is a side. 2, obviously 2 does not make a circle. So if I go, I'm gonna have to increase this to like 4. That is barely making a circle, but already you can see from the side, the wheels are touching. They're already touching each other, right there in the center there. So it's not gonna work. This one. Are there gonna be bearings on the axle of the mechanism wheel or just steel pins? I do have some steel sleeve, like sleeve bearing, so better than nothing. But that's actually gonna make things a lot more heavy. So I'm gonna try with the steel pin for now, see how that go. Then we'll decide what's going on. But anyway, and you can see the next problem now that we had managed to track the circumference of the circle is that we need to find the right ratio between where the pin lies and how big this roller is when compared to the wheel itself, because as it is, the two rollers are touching each other and it's not even making the full circle yet. So if I put it on the side view here, there's this gap between the shape. We can sacrifice some of that side rolling action by just deal with the fact that there will be a section of the wheel where it doesn't push 45 but it pushed forward instead. You can do that. That is an option. Not ideal for mechanism wheel. It's not gonna be smooth. Yeah, at least 6 roller, I think. No, it's gonna be as much as we can. Yeah, maybe, but yeah, maybe. I'm not sure. Any less and it's not gonna spin smoothly. Yeah, I'm worrying about that. Alright, so let's just put 3 down for now, because right now, oh wait, no, put 4 down first. Fix for 4, and then we do 6, and then we do more. Put 4 down, because even at 4, you can already see that they're already intersect there. So now we need to go, the way to fix it, what I'm gonna do, if we go to this first one here and increase the distance of from the center of the roller pin to decrease the distance between that and the circumference of the wheel, which is gonna make it less. All right, so 4 works. So 4 work there. So we got 4. So now we're gonna put it a bit more. Yeah, you may be right with the 6 there. Actually, you might be right. You might be right. Yeah, because it's still a little bit not great there. So maybe I'm gonna put 5 and then 6. Yeah, let's make it 6 now. Yeah, you are right. At least 6. You can still see a little bit of a gap there. But now we need to go and fix that again, or by change the roller pin here. This might be it for the Ooh, okay, 6. All right, that's too close. That's too close. Yeah, this gap is too big. Okay, put down a little bit more. Close. Oh. Alright, so the bigger this gap is, the less likely there's gonna be a pebble that lodge into this and lock everything together. So I'm not gonna make it dead close, but I do, however, want it to be fun. No, actually we're testing thing right now. We don't need it to be perfect, right? So let's go for the ideal one. No, for this. Oh well, there's a big jump. There's a big jump between that and that, whatever reason. Interesting. This is it. That's very interesting. What the hell? There's a different jump. I guess probably there's something to do with the parabolic nature of it, right? 5.5 here. So what's that? Ooh, Wi-Fi does not work. 0.75. Oh, nope. 7.5. That's the fact that I can actually change it. Yeah, okay, okay. Alright. So, save that first. That and that. Can I get a distance between those two? No, I cannot. Okay, never mind. Yeah, it's not touching. It's not touching. We should be fine. Okay. So now we got a ring of wheels. And believe it or not, we're not gonna, but this is just a part of the design. Right now I'm gonna grab this groove here, because the way that, so this body now, not roller axis, roller design, or I'm gonna call this roller designer. No, because right now I do not want this polar pattern here, because when you export this as an object to print out, you don't want all 6 of these, you just want one of them, right? What I'm gonna do is gonna grab that groove there, gonna make a clone out of that, the roller designer. So we got this one, but this is the one that we're gonna like finish up and deal with. Okay, roller. I need to use the bathroom. I'll be right back. Oh wow, it's only been 3 hours. I move slowly when I design stuff. Wait, no, that should be the other way if you enjoy it. It should be the other way around if I'm enjoying stuff, don't I? Why is that? Oh wait, now put the BRB away. Save. So the roller is that. And so this roller design away. Oh, let's actually lock this one in. Wait, why are you? Oh, shit. That. Okay, so wheel liner. Put that away. So we got a roller. We got a roller. That's a roller. Now we need a new body. We shall call it the wheel housing. Wheel out. Neck. Wheel housing. This is the part that is gonna be difficult to 3D print. This thing is gonna be the outer. Well, let's put up the old one again. Put up the old one. Oh, before that, let me give it a name so that I don't have to close it again. 2_3. Problem with this one here. As you can see, the first and foremost, the solution here is a little much. Didn't work too well. Right. Feel like coughing. Yes. So the problem with this design of this old design that I have here is that if the wheel hits straight down, it's fine. If it land on the roller, it is fine. But what it does, if I make, because I made this out of PC CF, so very fragile material, very tough but very fragile. very brittle. So when I land on the roller, TPU roller, it works fine. Just the one time that I drop it on the side, which is on this side here, it immediately shattered. It just destroy itself, pretty much. Pretty sad. Pretty sad. So yeah, gonna have to keep that in mind when I design this. Anyway, we'll do this over here because this is the main one now. And honestly, I'm gonna close that other one. Save that. Now for this though, I shall not grab the roller because the roller is a roller. But what I want is this polar one. I want this in as a reference. Then I want the wheel outline as well. Yeah, so not those two reference, just in case. Maybe put TPU sleeve on the housing part. Yeah, that's the plan. So my plan is, oh god, shouldn't that close it? Yeah, my plan is, I'm gonna build this thing mostly out of TPU entirely. So the housing gonna be a TPU 95A, so top stop, and while the wheels, it will be the same toughness as the other and a normal skateboard wheel, which is 985A. 85A is a normal toughness of a skateboard wheel. Yeah, so that's the idea. And the sleeve, and then the part that hold the pin, that's the key. The part hold the pin, i.e. the sleeve here, and then this surface in here. I'm gonna fill that up with something that is I don't know, the material with the least coefficient of friction that I can find. So we can use sleeve bearing, metal sleeve bearing with graphite insert for this guy in the center, that's mean select right there. But this on this side, I can maybe I don't know, I just put it in ABS or something, ASA or ABS or something. Just something tough so that it grip onto the pin while being plastic, and printing plastic is gonna stick to TPU. PTFE. Oh my god, have you ever tried printing PTFE? Oh, I'll tell you what, if I manage to print anything with if I somehow find a way to print PTFE reliably, I bet you I can sell this object, and not as just a design, but also as a literal thing for good money. No jokes, that actually is, because it's so damn hard to bring with that material. No, it's not the direct dry part that make me afraid. It's the warping and reliability between prints. That's creep me out with that material. Okay, what was I up to? How to best do this? Okay, I may not just want the circumference. I may want the entire thing, huh? Okay, then trying to think of a way to do this. Best do this. So, anyway, I was looking into PET actually. No, so if you I'm not the common PETG, but PET as in the material you use for water bottles, right? Those are actually pretty good stuff. Assuming that you can print it, they are pretty good stuff. Probably could buy a PET block and drill out a sleeve. I have cut block and made up that stuff. Yeah. I'm trying to find a solution to not having to. I should keep that in mind, basically. No, you can buy PET sleeve pre-made, like as an insert, so I can just make a little like a little pocket in this bearing, in this roller, so for PET for a PET insert, or two on each side, one on each side, and that is one way to do it. The reason why I'm trying to avoid actually on the housing, if you have an insert part, that insert is not part of the structural integrity of the component, i.e. the housing itself have to give some material away, which could have otherwise be served as structural stuff. To put the sleeve in. So yeah, for the roller here, yes, PET sleeve probably it, because I tried. Actually, I don't have the prototype anymore because a year ago when I threw it away. But I tried metal sleeve. It worked very well with the metal sleeve, but when you add up, well, six wheel here, 6 roller here, time it by 4, so 24 of these, 24 times 2 again, because there's 2 on each side, so 48 metal sleeve. 8 cost like 100 quid, and B, they are bloody heavy. The wheel themselves add up a lot. Then when you put it into a electric board assembly, that whole thing I would expect at least 10-20 kilo. No, not 20, sorry, 10-12 kilo as a whole, which is bollocks, right? You're trying to build something for that is like convenient, right? But making it so heavy would make it not convenient. That's insane. Yeah, I know, right? It's to be fair, I still have those rollers somewhere. One sec. They are very good stuff. They're like really well manufactured roller with good spec and all that. So they justified. No, they worth their price, whatever they were designed for. Just that for this application specifically, they are not meant for. Right? A cheap skateboard is not. That is have to compete with something like electric bike and all that. It is not for. I'm gonna find it. Maybe. Oh wait, maybe there's no way I threw them out. There's no way I threw them out. Let me just check a little. Isn't some. No, I probably threw them out. Yeah, I threw them out. Shit. I threw out 150 pounds worth of material of stuff. No way. Not be that stupid. Come on, I cannot be that stupid. Wait. Maybe. Come on. Gotta be somewhere. Gotta be somewhere in this room. I am a very careful man when it comes to spending my money. I swear. Alright, I'm not giving up on the fact that it's in here, in this room somewhere. I just don't know where it is. Maybe it's in the one of this drawer. Nope. God damn it. Oh. Yep. I cannot lose it unless I admit that I lost it, alright? $100 worth of... wait, no. There we are. Oh my god. Told you I haven't lost it. Told you I haven't lost it. Yeah. Oh my god. Here are the prototype. There we go. Here's the prototype. Metal sleeve. Very nice, very nice. The black stuff is PC GF. Oh, CF, sorry. PC GF. I already created the I already prototyped this what is it? 3D printed here because the metal one that I bought is super heavy. But these guys here from Yeah, these are great, amazing when it comes to how smooth it make the bearing feel. Right, these are amazing. Just expensive. Yeah, these. If it wasn't for this fragile housing, this one would be really great as it is. And the one that broke is this one here. Yeah, you see. See here. I drop it on the corner, and immediately that side just shattered. And once again, if you look on down directly at it like this, you can see that there's barely any contact surface for the roller at all. So this design, the way that this was designed, is not the way that it designed itself was wrong. But yeah. Oh yeah, you can see this. What's this from again? JLPMC. I'll look up after the. I will look up the website now. It's a Chinese website selling mechatronic stuff, and the reason why I'm so highly was it positive about them is because that unlike Amazon, not a lot high bar, but unlike Amazon, they give you the perfect amount of JLCMC. There we go. Perfect. Yeah, they give you the spec sheet for what you're buying for. So your linear bearing there. Let's just grab. I need a sleeve. Where's the sleeve at? Sleeve. A sleeve. Bearing. If you know what you're looking for, that is. Come on. Sleeve bearing. What did that thing called? Oh, bushing. Oh wait, why am I not typing? Yeah. Oh, they got copper one. Got copper one, position pin. Yada yada. Hello. Totalist. Yeah, yeah. Oh yeah. Oh. Damn, I want them already. Oh, there it is. This is the one that I'm thinking about right now. Yeah. Oh, poly Teflon, blah blah blah, PET. What's it called? Yeah, the pushing. This it's not exactly. There's not no. There are industrial term for it, but they don't use it consistently across the board. But pushing is what this guy call. Yeah, see this is a godsend for me right now. PTFE, yeah, PTFE. That's that's the word. Yeah, PTFE sleeve, and you can see that they give me a full spec sheet. More importantly, if I can zoom in, yeah, I can. Yeah, see, tolerant. 3-digit tolerant. Holy shit, it is expensive. Let's be real now. £1. Remember, I need like 48 of these. Yeah, I need 48 of these. And 48 times 1 here, 1.5 here. Dollar, by the way. And where the goddamn calculator at? Calculator, where are thou? God damn it, oh, there you go. So 48 times 1.5 here. Times 1.54? 55. So that's 75 quid. $75. Add in like a shipping cost, because this is without shipping costs from China nonetheless. So especially shipping costs nowadays. So let's just take that by 20%. So 75 times 7 4.4 times 12.25. That is 93 pounds. So yeah, 70 bucks. 70 bucks. Yeah, no, so 93 bucks if you are if you're shipping. Add shipping to it. So yeah, this is not. Oh wait, no, shipping estimate. Seven that much. Eight. Oh wait, never mind. About 80 bucks to send this thing to you. Not great, but once again, come on. With the inshitification of Amazon specifically, this spec sheet is a godsend. So yeah, what's the funny part is that they actually they offered me to for was it collaboration on this project year back, but then I just keep pushing it back, and then eventually they just give up on me. So unfortunately for me specifically, because don't I can't blame them for that, but I will buy this regardless. So yeah. So that is that. Where was I with this? Oh yes, we need to draw it first. Not draw it. So what? We need to do a bit of importing here. Ow, my neck. First, I need to make a wait. No, don't need to draw this outer line here out first. Okay, so first actually how to do this? Yo, you should ask them if they're willing to send you some. I did. No. They contact me first. They sent me the metal version for free. That's the key. They sent me the metal version for free. I think the problem with me specifically is that this project is hinged on the other project over there. Those printer, that printer over there, that printer right there. I need a 3D printer that can do multi-material reliably before I can do this project here. And that is a big liability across the board in every sense of the word. Because if the printer gone down, I have to go and spend a month or two go fixing it, right? That's not how good partnership works. So I don't. They already sent me the metal sleeve in here. I appreciate, and I find it to be, and I don't want to make use. If I am to be a partnership, I need to be able to be confident in myself to bring something to the table for them. And as it is right now, I'm not even a real YouTuber. My YouTube channel is not monetized because I don't have enough watch time. So for me to go and call them up and go like, hey, just give me $100 for free. That's no, even if they give it to me, it's like it reflects badly on me as a person. So once later, if I were to actually get monetized and be professional about it, they may never pick up a phone from me ever again. So I just for now, just buy it. I'm not big enough of a person to go and ask for free shit right now. Where was I with this roller thing? Alright, so the one thing that I noticed now, if you look on the right, some of these wheels protrude outward a little bit. So one way we can handle it, and we can just ignore it, to be honest. We can just ignore it. Basically cut out a little groove, cut out a little groove on them on the corner, maybe. Actually, let's try that. Let's try that first. Let's try that first. So how are we doing this? Okay, wait. Okay, I need I don't need a roller here. I need a duplicate of it. So like that. Can I track that in here as a base feature? No, I cannot. Clone it. Just clone it, yeah. Clone it, put the binder in there. Okay, we rebind it later. Rebind it. We rebind this one in, another clone, sorry. Rebind it in. I want to cut out most of the material first, and then I'll use a Boolean function to trim out the actual shape of the wheels later. That's the plan. We got the shape of the wheel, the binder here. So next we need to go to this space here. Dimension on it. There's that projection here. Grab that and that. Got the equal. So I will drill out as about that much. So dimension. Yeah, 40 is good. 40 is good. We shall cut it. Cut it on both sides. Not reverse, sorry. Symmetrical. And for, let's see how long. Okay, to the edge here, that right to that edge. I'm not sure about that actually. Now that I think about it. Maybe that is enough. Actually, let's go right about there. There. Okay. Right. So then I'll hide that. That is the shape of the housing. We need to chop it in half and later. We need to chop it in half and add stuff to it later. But that is for later. Now what I want to try really quick. What's this now? Housing template. Wheel. Housing. Template. Plate. Polar pattern. Make a clone of that. What I'm doing with this one. I'll take that. Add. Double click. Click to enable it. And I do a boolean to it. And I'm gonna remove. Wait, sorry. Add body. Add body. Add that body. Oh, didn't do. Indicators. The indicator for add and remove button does not work too well. Anyway, that's what about it. Well, see. Now I have a. Oh wow. That was really smart of me to just about there. So maybe another millimeter or two would make this parallel nice. That is the shape that we want. Okay. Is it? No, it's not. God damn it. Ah, damn. No, that's not it. That's not the one. Yeah, no, this rim right now is the same diameter of the wheels itself. It's not correct. I need to trim it down. So basically that rim is not meant to be there. But good news at least. Wait, what's this pocket do? Oh, okay. Okay, no, we can make lemon out of this lemonade. What we do is, okay, we can call this is will be the cut that define the depth of the tire, basically. That one, let's just turn it to speaking of the depth of the tire, so how deep can we make this tire? So 100, let's say 10 mil short, so 90, right? So actually, while we at it, there is one thing that I don't like about this old sketch. Wait first, that I don't need this line. Turn that one to that. There we go. Small change, but you know, later stuff. I'll cut this. Whoa. Okay. What does that look like? Ooh, this may look like, oh yeah, it look like regret. You see how much material this happened right now? That's not enough. That is barely enough. Oh damn. Oh damn. Oh damn. Alright, let's just grab that line here and see how much I have there. 2 mil. Yep. If this is the sheet of metal, that would be perfect. A 2 mil aluminum blade being bent into shape and used as like a actual commercial mechanism wheel would be perfect. We are designing for 3D printing. It is not great. Let me just put the thing back on and think about it for a minute. Roller. Obviously, there's material that we can trim away here. But as for the wheels, yeah. As for the wheels, oh damn. Oh damn. Yeah, this whole section need to be made out of PDG, out of TPU for it to even work. It's not great. So, I need an offset from that surface and that surface there of the housing itself. There need to be an offset. But such thing. Oh wait, this. Why is there a groove there? Shouldn't be there. Isn't too small of diameter? Isn't it too small of diameter? I mean, you mean the housing? The housing or the pins? Because I can look at both right now, and both not good. Maybe. Yeah, no. The housing, yeah. So the housing right now, let's see. There's something wrong with the design as it is. So yeah, there's something wrong with the function that I use here. So let me go back anyway. There's too little plastic with snap. I think yeah, that's the problem right now that I'm trying to solve in my head. We need to pad up this hole. We need to pad up this hole. Pad up this hole. Close up. We have been in measuring mode the whole time. Just, god damn it. Recut and that's good. Close that. Alright, let me just put this in what it called construction mode. We'll just draw. Yeah, there's some problem with FreeCAD right now, so just give it a hard minute. Give me a hard minute. 120 like that, so there's no. There we go. Yeah, FreeCAD because the way that it renders now. So we'll take that. Okay. Alright, we'll just do this for now. I'm not gonna keep this long term, but I'm gonna do this, and we need to come up with a plan basically. Where the heck? There we go. That, and we are going to give it. Wait, no, this. Do that as well. Wait, no. First of all, what we need to do is reduce this. So a 10mm tire is what it was would have been perfect, but I think we have to stick with a lower number. So give it. So it was 2.8mm in terms of space, so also give it not 3. What is 6 mil? 6, so oh wait, no, sorry. So from 8 from 90, you need to go to 96, adding 3 millimeter just from of material, just so that it can actually do that. So yeah, buff up the hole just a little bit. I like that. Oh wait, can I select the surface really quick? That's before the sketch. Ignore the sketch for now. I'm not doing this proper just now, just yet. Not doing this proper yet. Just need to figure out what's the right thing to do first. So let's go back to 90. I am not giving up on this yet. Just once again, the more the bigger the housing, the less tire space contact we do actually have, and in other words, the faster this thing gonna wear down. If I take that and I'm gonna extrude it, can I extrude that to up to face? Up to face. But if I do that, what's gonna happen? Oop, no. Wait. First. One side. Reverse, sorry. Reverse. And dimension. Yep, there we go. So if we do something like that, what does that mean? Let's just think about that really quick. And re-enable. Oh. Okay, so the problem here is in this angle, where you see this line going across there. So the more I push that line, that holding out. Yes, we do have a little more plastic, but now because it's at a 45-degree angle, you actually increase the diameter of the total circumference. So if I put it in this view, for example, you can see that yeah, it's going to start poking outward from the circumference. That's annoying. That is annoying. Gonna snap. Definitely gonna, and yeah, no, this also, it does not help with this gap here. Does not help with this gap here. Okay. Grab that. Come on. There's too many objects on the screen. One sec. Write that away. So if I take that again between here and here. Yeah, this is definitely gonna snap within seconds. It's less than yeah, that doesn't help. So I have to increase this. If I want this to this that's annoying. Like that padding. I think you should make the actual diameter of the housing bigger, as big as possible, maybe a little thicker, a bit width wise. Yeah, that's oh, and it crashed. Count it. I count it. It's a bug for free cat. Okay, let's count that as a bug really quick, and then we reopen it. Let's see where did I save? Where did it save? Yeah, that's what I'm saying. Bigger the housing, the less tire space that we actually have. Right, so let's say here, the housing housing of this is defined by this inner circle here, the diameter of it, and the gap between this reference line and that circle is the gap of exposed depth of the roller. So in other words, the less gap that we have between that line and that line, the faster this wheel will gonna stop functioning as a mechanism wheel. And it's just, you know, once the roller wear down to this inner line here, the housing becomes the wheel itself, and you basically just have a normal wheel. So I went from 90 to 96. Oh wait, no, actually I had yet done that. Close it. Yeah, remove that. Don't need that yet. So if we go from 90 to 96, and we grab these two lines now, trying to get a distance between them. Yeah, it's an increase in by 3 millimeter. Right, so we got a 4 mil tire versus a 10 mil tire. It will be a dependent. It will depends on. It will depend on how often are people gonna be willing to change out those roller. FreeCAD certified classic. Yeah. Well, to be fair to FreeCAD, they don't happen all the time. So there's some version of it that crash all the time, while there are other version that doesn't crash. So wait, no, not version of FreeCAD. Sorry, yeah, because FreeCAD is a combination of a lot of things. Combination, I cannot say that word. A combination of a lot of things. So the assembly workbench, for example, is very, very new. If you mess with it too much, like if you push it too hard, it will crash your FreeCAD, and sometimes it will even break your entire model altogether. Right? It was a major problem for V1.0.0. It is less of a problem now with V1.1.1, but every other the workbench, for some reason, in this particular version of FreeCAD, suddenly have less compatibility and less reliability. So it's like it's a give and take, and it's just funny. It's just funny. All right. So first, so let's make a decision now. Because right now, once again, it's just it's still prototyping phase. So let's make it for. You make the roller thicker, the wheel bigger. To account for the bigger roller, you will get more plastic around the axle because it's depending on the diameter of the wheel. Yes, but the bigger wheel is also bigger wheel. I try up to 150 millimeters. So this one, the size of my palm here, is 92. Is it correct? Yeah, this is 90, no, this is 96, 97. This is 96 mil. So 100 mil is around there. Okay, 100 mil is still bigger. And that 150 is around here. Oh my god. Where is it? Let me just go to the desk view here. So this thing, the size of palm for comparison here. The size of my palm here is 96 mil. 96 mil from the roller, not just the wheel. But yeah, it's already quite chunky. Let's see how weighty it is. This one on its own is already 561 grams. So 4 of this is nearly 2 kilo. More than 2 kilo. So yeah, so bigger is, yes, the mechanism wheel seem to be more it's more it's better to go bigger for the mechanism wheel, but at the same time bigger is heavier. This is going to be a pain in the butt to dampen for, and when you mount it on the skateboard, right? The free mass problem is the real thing with dampening a vehicle, especially something that's meant to go on rough road like a pavement, UK pavement, gravel, pedestrian or walking path, whatever we call it. So yeah. No, so we do have to keep that. No, you're not. It is exactly what. No, I got this. Was it? I printed it out. Actually, I actually designed and printed it out the version with like 150 mil wheels. Well, because you are exactly correct. In fact, you validate my my effort with that side on that side of things. 150 is seem to be the perfect. It seems to be around the right number for all the for the parameters of the plastic to go in correctly and be tough enough. But at that size, for one, you need more than 6 roller, i.e. increased number of sleeve bearing that you need to buy. And for two, it's plastic itself add up in terms of weight a lot. So things can go sideways quite substantially. So for now, what I'm gonna do, that's why I landed at 100 right now, because this small one here proves that 90 something is not good enough. So I want to go to slightly bigger, slightly bigger, and trying to get a weight. No, 90 something is not good enough, especially if you're trying to get trying to get a roller exposure, right? So if you look on the side and you don't see the roller at all, that's not good. You need the roller to be exposed so that the roller can do its job. Right now, this thing, for all the cool stuff that it looks right now, it does not work as a mechanism wheel. It works as a normal wheel, because the roller itself doesn't do anything. It just, what it's gonna do is that the rim of the housing here gonna get caught on the roll, and that becomes, maybe make the wheel at a lower angle, actual less tilted, so you can get more plastic around it without getting the extreme radius of the tire. Yeah, actually that might be it. Because ultimately nobody said anything about this happening to be at a Pacific at a perfect 45-degree angle, isn't it? In robotic, that would be nice. In robotic, this roller being at 45 is very convenient for calculation. Yeah, you're restarting. 1 sec. I swear, I have a feeling that's partly my fault at some point. Right, you're here. Right, so yeah, in robotic, like if you are working on a robot running in a factory or something, 45 degree is a very convenient angle, because it means that you can go left as much as you go forward. Going diagonal, so you're going left as much as you are going forward. Yes. So it's very convenient for calculation, but we are doing something that we're gonna throw on a street. So 45 may not be. Yeah, so it may not be reasonable to go and trying to mimic, trying to bring a robotic angle towards the street, right? So maybe if we give up on the not give up, I need to make a copy of this. Wait, what did I just do? All right, yeah, okay, close that. All right, so just save this for now. Just save it. Right now, where it is right now is something, because what we're about to change is very fundamental. It's gonna break a lot of things. So let me go and make a new version of this. Close this first. Yeah, close that. Underscore O. No, 0.0. 0.0. If you need to small sideways movement, you can get them as low as 22.5. Oh, you tried it before. All right. Yeah. So my plan is that I only want sideways as a gimmick. Not gonna lie, I want sideways motion as a gimmick for me to play with. Like if you roll down a road with one of these wheels, gonna turn a lot of head on its own, and then you stop at some way and go like, oh god, I need to go sideways for a sec. That's the idea. Right. So let me do this something. Let me organize my folder here. So yeah, let us first create a dash O folder. The old one in there, the new one, which is a copy of it. 2.1. Oh. With this, I can now be all happy, very keen. Go back here. Now the what gonna change this is not change this. Sorry. Wait, what's that one? Where that one came from? Oh yeah, that's just perpendicular to this face here. Haven't tried them out and on, but I'm graduate from robotic and electronics, so I'm studying motion system pretty deeply. Yeah, I can tell that you're well versed. Yeah. All right, so where was I with this? So 45. I need to know which direction is 45 really quick. That's more. So if we go for, you say 22.5, right? I'm gonna take 45 divided by half and then round it up. 22, yeah, 22.5. All right, so call it 24, negative 24. Oop. Negative 24. Wait. Maybe 25. Yeah, we call it 25. It's not that it mean anything, but just look at my old friend. Yep. Welcome to my world. Good thing I make that backup. Okay. Let's try that again. Now. We may have to. Oh my god, I may have to redo everything. Not even joking. No. The reason why it crashed there is not a bug, but rather because there are so many calculations that rely on each other. We are changing literally the very first thing we ever made, right? So everything else that built upon it will have to be updated, and along the way something must have broken. So I'm gonna delete the housing for now and try again. Yeah, so not only do we changing the not only did we just gonna change the angle of this roller, we know there's two random planes that need to be changed now. The first one is one that is perpendicular to the roller here, and the one is longitudinal. I don't know, that's the right word? I don't think that's the right word. But that one and that one, yeah, these two need to change at the same time, and unless they are changed at the same time, they're gonna break. If I don't do it at the same time, they're gonna break. You have to change the angle in and out tilt. Also, I would think it's less hard on the pushing because you let less actual force and more force on the opposite side. You have to change the angle in and out the tilt. I don't know how to explain it. You have to change the angle at the in and out tilt. Yeah. So this is a good demonstration, the best. So right now, this angle here is 45 in comparison to the wheel, right? So we want to turn this a little more like this. So go from 45 to like 25 here. That would probably give us a little bit more leadway in terms of how much material we have to support the wheel. Problem with it is that because the way that I draw it, the drawing that I have made here is dependent on two different planes. This plane that is go through the axis like that. At a normal with the axis like that. That plane, and that plane there, that is going along the length of the axis. So if I try to change one and not the other one, not the other one, the whole thing gonna break, and I'm concerned that I may have to redo everything instead of just update it. Oh, one. That one didn't break. That one did not break. Wait, what's this one? Cancel. Ooh. Oh, that one there. That's the other one. Yeah, that's the other one. 25. Maybe export just one roller and make the new file. Nope. So what just happened? It's working. It's working. Give me a minute. Give me a minute. Give me a moment. I think this one is wrong. Yeah, this one is wrong. Wait. How do I do this without having to do this again? Selecting. Oh my. Oh shit, we're doing this again. Then with 45 degrees for that. So basically, I'm changing the reference point. I'm changing from the original XYZ to use. I reference the second plane on the first plane and make it 90 degrees. Sorry, 90 degrees from each other, like that. That way, everything should. This, of course, it's gonna break a bunch of reference, but the way that what's going on now is that for FreeCAD you need to go into a sketch and get out of it for the recompute to happen. For recomputing, clock is ticking. I'll join you on Twitch because YouTube keep breaking. Ah, okay. Yeah. Hey, that's the. Ooh, what just happened? What just happened? Oh my god. Okay, let me grab this padding here really quick. Let's start from the top. Start from the top. That's not the top. Where is it? There, oh, there it is. There's the top. Okay, so let's go along that line. Yeah. Then, right there. Ah. Oops. My bad. That's the wrong way. That's the wrong way. That's the wrong way. I was pointing at where I put that. Okay, yeah. That's the wrong way. Wait, what's that? Then the plane. So grab that random plane there. Not what I was looking for. Oh my god, I may have shot myself in the foot with that one. Okay, brought back the origin, yeah. Change it from 90 degree. Wait, 90 degree from what? I'm going crazy. Hide that one for now. Yeah, that's the one I'm looking at. If I am, hide that binder as well. Okay, I'm reverting. Reverting back to whatever was working before, like that. Get rid of the housing because that's the thing that broke everything. Roller here. No, not that one. Roller here. Push it. See it. Cancel it. Anything, whatever I was doing. Cancel whatever I was doing. Expose the random plane. First random plane. Yeah, random plane. Oh, there. Okay. So I got it upside down. That's why it was weird. Okay. Okay. So that's the one. Let me just figure out where that is. So I wanted to tilt. Oh my god, I'm already lost track of it. There we go. I wanted to tilt clockwise. Before that though, let me grab that random plane 2. Random plane 2. That random plane 2 there. I want you to reference not the original plane by 40. No. And then a plane 2, right? Just making sure. Yep. I want you go just reference that one at -90, like that. So that way it broke because it's technically going to result in the exact same thing that it currently is. What I can do now is when with that one, I can go from, oh, I see now. All right, I need to go down to 25. Okay, would that work? What's with that other one? Okay, yeah, just recalculate that for me as well. That's good. Polar. And did it work? I got no clue if it's working. No, it's not. We need to redraw the sketches. That. And it worked. It worked. It worked now. That's good. That's good. Yeah, so you can see the roller is no longer that have that extreme shape to it, right? That doesn't have that extreme rolling shape to it anymore. And if we can look on the rear now, oh, we need to add more. What? What's that sound? Add more and make it smaller. Yeah. That's the plan. Or you can make it bigger. Yeah, this gap is huge. We can make it bigger first. Let's try making it bigger first. Wait, no. Yeah, let me make it big. No. Let's try it first. Try make it bigger first. How do I make it bigger again? We take that one. 36. Uh, 36. No, that's fine. Let's just keep it at that angle for now. Make it 40? Wait, no. So going down. So make it 32. Oh yeah. Bigger roller, better. Alright, 32 is not good. 33? No, 34? What happened? What did I do? Oh, I think I pushed it too hard. Yeah, I think that I got what's going on. Let's Control Z this. Problem with this, the problem with the reverting from this point is that the recalculation is not reverted. Also, bigger roller wear more slowly. Yeah, that's the idea. If you start with a rim instead of the roller, which is what happened here over this guy. You start with the rim, the housing first. Roller gonna be tiny. Like, once again, you don't see any roller exposure here. And so this whole thing, although it looks cool and all, it's just a normal wheel with some rolling bit that can break in the middle. That doesn't do anything. And also, this whole thing is I don't think it's clear, but there's a clock running on. So basically, whatever I have done is just caused it to slow down now. So just chilling. Uh-oh. Oh. I think it's killing my computer. Uh-oh. Yeah, we're hitting the limit of my 16 gig. Oh, yeah, the chat just got restart there. I'm not sure I'm not sure if that free cat. You. Oh, right now, I can see it right now. CPU usage 70%. All right, just give it half a minute. We'll get there. We'll get there. Oh, I look into build, and I'm seriously. Well, I was seriously trying to look into getting a new PC right now, and guess what? It's like 2,500 pounds, British pound. So what? 2,700 bucks for a PC that is better than what I have right now. So there's no way in hell I cannot pay any of that, right? I know it's a 5 years old PC, but there's no way in hell I will throw out that money right now. Are you seriously gonna crash on me? Alright, let's put that there. This is now gonna be a FreeCAD. Yeah, for me to upgrade is about the same low. No, the funny thing is not for me. If I'm not oh wait, no. No. If I keep doing CAD the way that I am doing now, yeah, there's no other choice for me. But yeah. We just this is now a FreeCAD waiting stream. And why is it going up and down so heavily? Put that one there, and for things to actually happen. Come on. You can get there. I didn't even do that much, did I? Oh, I'm afraid of just. Part of me want to just kill the process and restart, because it was working until I dropped the number down so much that it break the other sketches. So. Okay. We're killing it. We're killing it. Goodbye, FreeCAD. It was good knowing you. Alright. Give it to me. Where did I lost? Yeah. Original file corrupt? Yes, please. Thank you. No! That's not it. Uh-oh. Oh crap. I fucked up. Alright. Calm down. Calm. Stay calm. We can fix this. We can fix this. First, hide the binder. Yeah. Stand. Calm down. Slowly. Be chill. Grab the second one. And angle it to reference it. The first one, which is that one. Outside, which is that one. Yeah. Rotate it by -90. Yeah. Now, yeah, that's good. Okay. Nothing else broke. That's good. FreeCAD still not giving up the ghost yet. Save it first. Control save. Yeah, save it. Okay. And then grab the first one. You're on the first one, right? Why is the roller plane cannot cancel that? Put the roller origin on. Grab the first one. Yeah, grab the first one. Now we shall put it at 90. Wait, what am I looking at? 20 something. Just, oh my god. So I'll explain in a second what I just did, what I did wrong, and what I should have done. There's a chance that we might have to go and hard reset this model. Yeah, I have to hard reset this model. Damn it! Ah, darn it! Wait, what was that? Yeah, no, it's all good when done now. So good news is I can delete this. Just delete the old model, grab the old model, rename it 2.1. So this is why you make a copy of a copy and not just relying on the revert function. Oh yeah, so there's two ways to do it. No, there's two layers of safety there. So there's this revert function, which is the automatically save every 5-minute things that the software have, and there is what I did a minute ago with the file browser over here. Oops, I need to go there, yeah. I literally made a copy of it right there before make a copy of it of the old version, and then just edit on top of that instead of relying on just the safe stuff. It's just a layers of safety, because things can go wrong. That one is that second way is manual, so it doesn't always happen to be the most up to date. But sometimes, like this time, the if you save it, automatic save it go off too often. What happened? What you see? What happened there was that it saved the version of the file that is also already broken. That's why we didn't get we couldn't revert back to a good save. So I put that back there. We want that one, and we want that one. Yeah. So once again, that one. Shall click on select. Oh god. One. And then we go with it 90. Okay. And broke. Good. Save it. Now I just need to religiously save everything because I've got spooked. That one. Yeah. Instead of 45, I shall reduce it to 25. Okay. And it's not has not been updated yet, so save it first. Important, very important. Click on the roller here. Let go. Bada bing, bada boom. Nice. So save it, because this is where the experimentation gonna go, and it going to break some stuff if we push too far. This is pushing this too far is what broke it the first time. So I'm gonna put it 34. Make the roller bigger. And it broke everything. You son of a bitch. Okay. What am I looking at? This is a roller. Revolute. Put that revolute in. Yeah. Oh, that's why. Oh wait, no, wait. Put up all the addendum plane really quick. Because I may or may not. Oh, hello. Yeah, there we go. So, put the binder in. Well, makes a lot more sense now. So yeah, what I did is I draw these sketches to meet find the rough. Oh, actually, let's mode this here into transparent, and to find the rough position of the contact between the roller and the wheels form that we want to emulate. Right, those are the one. Why is this one Where's the one in the middle? One, right? Yeah, there we go. Okay, and okay, so the revolute doing fine. So what's this groove then? Ah, there it is. There's the problem. Oh, nice groove. What the hell? Ah, I don't know what I'm looking at. I'm gonna delete everything. Delete everything. And then, cut away. Cut away. Yep. Just like that. Oh, what's this? I don't need the skeleton there. Okay, I just need to now start collecting. Where is it on? Wait. Something fell a little off. I don't know what it is. Oh, right, because it's no longer 45, so the shape doesn't look the same anymore. What worrying me right now is the fact that okay, I may just want to trust the process here. Am I crazy? No, because you see this point here just poking out of the wheel. It was like, wait. But technically it's working. Technically it's working fine. Technically it's working fine. Alright. Enough. We'll just do it, and then if it doesn't work, then it doesn't work, then we'll do it again. And also this. What's happened? Okay, let's hide the revolute itself so that I can grab the line there. What is going on there? Uh-oh. That line okay? Okay, let's go check that one out really quick. Yeah. That's not that one, the one next after that. Yeah. That's okay. And it's gone! Ah, there it is. Hello? Recat? Can't select the line. Oh wait, no, I know why. No, I don't know why. What the hell? What? Why are you broken? Count it. We can't go up. Oh. Okay, it was 56 before I start. And honestly, this FreeCAD counter here is supposed to count for the MissChanger project, so we can just lock it down really quick right now. Yeah. Let's just lock it down. That 56 is the number for the 3D printer project, yeah? And right now is making a wheel project, which not even goddamn working. What are you doing? Wait. Why aren't tile working? Okay. 9. Alright, that's it. Get rid of that. So the way that I did designing this right now, it goes as first. Get rid of that. Get rid of that. Get rid of that. Get rid of that as well. So that way I can have everything here. Grab that face. That's the one that we're using. Draw on it. Ooh, roller design. Yep. Okay, basically just clean up a slate as possible here. So I delete everything that follow it, which was not much, which is good. Alright, draw the B line here. Yeah, doing that. Okay, we'll grab that point. That point. What? Huh? Oh my god, what just happened? Oh. Fabrico, Noah. I can see what you're doing. Copy, open link in new tab. Yeah, I know researchgate.net and all of that, yeah, but give me a shout before you do that again. Don't, you know, it's Twitch. On Twitch they literally spam. There's what's it? There are Twitch bot all over. There are Twitch bot all over that that spam like porn link all over the place. So that's why I ban. I basically there's a blanket ban to all links coming through Twitch. All right, let's grab the link. Let me grab the link here. Okay. On page 5, there's an equation to get the curve. Ah. Okay. Let's see if we can get it. I never used the equation with the download full PDF. Yep. Dun, 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 dun. Oops, wait 2, wait 3, 4, 5, 8. There we go. Basic geometry take account to that, where L is according to the equation that. I need to read the whole thing. God damn it. Okay, temporary contact the roller based on the relationship driven rotation. Yeah. That 45 5. Ooh, this one take into this one did make the assumption of 45 degrees. Yeah, I'm gonna have to digest this. Hello. Hey, look at that. Oh, I knew it. There's some. It's pretty complex. I'm not sure how to apply it. No, it's that the applying part is it's not that complicated. The way that they work out actually is you break it down. Actually, let me open an older version here. So you break it down to the plane to 2D planes, and then just make some calculation and then calculate some more relative to each other. You work to eventually work to where it is, which is not that difficult. The problem to me is actually how to apply it to FreeCAD. Right? The problem is how to apply it to FreeCAD here. So thank you for the paper, and honestly, I'm gonna download that really quick. Make sure to do that before I forget. Yeah, making them wheel. Oh, actually, grab the name. No, it's not even brute forcing. It's not about brute forcing a bit. It's about how the software gonna take the equation specifically. So when time come to let me move this around. Download for making them wheel take account of modeling of the mechanism wheel. Where the geometry mechanism wheel. Yep. Oh, one sec. Download that. Very important. I'm gonna have to go and read that. Been a long time. Okay, let's try to open it really quick just to make sure that I have it correctly. Yeah, there we go. Okay. Equation got a little fussy. Maybe I need to re-download that again. I closed the download page folder. Yeah, it is proof for that. What? That is broken again on Twitch. Yeah, funny enough, Twitch is always broken for me for whatever reason. Yeah, I think the old one got a little bit dodgy because I closed this window before it finished. Anyway, for now I have to brute force it because it's reliance on all the feature is contingency on this on this sketch. And honestly, I'm not sure how that's gonna play out if I were to put the equation onto the sketch itself. It may make it more reliable, alright. In fact, that might be the case, but it can also make it more painful later. But for now, we just have to play it the way it is. But yes, I knew it. I knew there's gonna be a point. Oh wait, no. I knew that some nerd probably had figured out how to calculate how to the geometry of this roller. Knew it. Equal, symmetrical, and yeah. If not for nothing else, I'm gonna use that. I'm gonna read that as for information. Why is this not working? Okay, it's working now. Oh, not this. Yeah, it's this. Right, symmetrical. Alright, I need to oh, there we go. There we go. Boop. Shit, carton. One and that one and that one symmetrical. That's all right. That's it. Up, push the rough shape that I need it to be. Connect those. Connect those. Those. It's always smarter. Yeah, this shape, I don't know what these lines are for. I don't understand it. Sure, they have a purpose here. One day I will find out if I ever feel like it. Okay, that's it. That's good. That's good. What now? We need to cut it. Yeah. We need to draw line up, over, and down. At that dimension. Oh, I think I know what happened. 20. I think. Yeah, I think I know why it was having trouble before, because if you remember, I used the lock function, this one here, to lock it down like that, and basically the shape just got locked in, and that function is very far-reaching, so it forced this whole line to stay where it is no matter what. So it was a miracle that it actually did manage to do what it do, managed to be constrained to alter itself later, and it was before. Oh, actually, if anything, I can try make this a little bit more, not robust, sorry, just I needed more. Oh, what just happened? Oh, I'm just messing this up. It likes to dance, but it doesn't break anything yet. Okay, so if I grab that, barely see it. I hate the color scheme that I given it right now this time. It's gonna be a pain to. Oh, god damn it! Don't see it. What we want. I'm trying to delete. Oh wait, you don't see it. Better see it. But I'm gonna Control Z until I get rid of this 21 here. Yeah. Yeah. Well, too difficult to. Yeah. Let's just brute force this from there. Yeah. Let's just do this. Let's just do this. Folding cut. Around. Select. Yes, please. Axis to vertical axis. Select reference. All right, there we go. There we go. Perfect. Okay. We'll do. Oh, what's this in the middle? Interesting. Yeah, over. Whatever. We now gonna hide or are the random plane. No need for them no more. All right. So I'm gonna grab this whole thing and I'm going to rotate it. The y-axis for 1, 2, 3, 6. Yeah, 6. 6 is still a little bit. Can I? Oh wait, no. It's 7. 7 is pushing it, huh? No, 7 would work great if I don't care about the rolling pin, the distance of a rolling pin. But let's try for 6. Quite close in of itself, huh? Maybe not. Maybe we may have to go to 7, not gonna lie. May have to go to 7. Then we put back the binder here. Yeah, you see there's a large gap in between this roller. Okay, now let's test it. Save it. Control S, manual save. Push it up. That's 34. Oh, 34. 35. Close that. Make it. Yeah. 35. 35 is, yeah, so. That look good. No, there's still some gap in between them. It is better than the last one, but there's still some there's still some gap between. No, so now here's the determining factor here. Okay, if I put it down to 34, yeah, so making the roller bigger. Start touching, right? You can see it's touching, little patch of touch in there. But even then, if we put the binder back on, you can see there's still a gap here. Gap between the rollers. So we may have to go to 37. You can also make the roller wider instead of bigger. Yeah, just extend them outward, right? That actually ran into the same problem with the that's lengthwise. Yeah, that's Oh yeah, I see. The downside of that is actually I'm not exactly I don't exactly have the what you call. I did not do the right thing to set that up, but we can do it. Let's try it. So now this is 60 mil, so we're just gonna push it out a little bit more, right? So where is it going? Adding. Oh no, this cancel that. This doesn't matter. It is this one. Yeah. Well, there we go. This is 60. Give it 10 more. 70. No. 5. This is 65. Not that desperate. Okay. Alright. Okay, so it's shape is hello. Alright, let's put this now to 34.5. Just up more. Yeah. Oh, so close. Yeah, we can push it. No, so what worrying me right now is that it's the end of these guys here. Wait, no, it's not that even. Oh wow. I'm still in the brain of that 45-degree roller. My brain is still at 45 degrees, so I was constantly worrying about this going poking out too long, but it's 25 degree and it's look like we got a lot of room actually. Never mind. Yeah. Let's play with this. Let's play with this. So sketch it yet. Well, first of all, let's make sure that this thing is not touching. It's not touching. That's good. That's good. Oh, revolute. That one. All right. Make it 75. 74. 74. 74. 74. Make it a round number, even number, so I can divide it by 2 easier. Yeah. Holy shit! That actually that might be it. That might be it. Yes. Now, so if I zoom out to 100 to the full 100 here, you barely see the little sliver between them. Ah. Push it one more time. There's a lot of area left, so we can push it one more time. All right, 80. This is almost going to be make it almost at big. Oh. All right, 80 is good. What I'm gonna do now, I need to go and recorrect the shaping of this tandem plane, because the these tandem plane here are hinged on the fact that it is a 60mm length roller. So if I can find them, let me put the ball back. First, hide the binder, hide the polar, put the groove back on. That's it. Put the groove back on, yeah. Put the groove back on. Now put all the tandem plane back in place. You can see what they're up to. Yeah, you see that the tandem plane is not exactly correct anymore. And do is 80 divided by 4, by 2, sorry, by 2, 40. So that's the first one. That one. Huh? I need to know which one is what. Okay, that one is not where it's supposed to be. Phase 5, -7. Yeah, they should be flatter now. Yeah, I know. But the thing is, because the way that I brute force it is that I just take these plane like mid section at a specific distant interval, right? So right now, because we changed the length of the roller, that middle one, for example, is not at the center anymore. So I need to go and do it. So I need to redo it. So this one, cancel that first. That's not the one I'm looking for. This one is the first one. Yeah, that one, the first one. That's good. Second one. Okay, second one. How many do we doing to get? 1, 1, 2, 3, 4. Divided by 4. So 20. The first one is now. Wait, really? No. 40 divided by 4. Sorry, my bad. 10 mil interval. Oh wow, actually that worked out better. Oh, close that. That one. No, it's not that one. Sorry. Right, that one is -10 instead of 7.5. Oh, sorry. Like that. Need to be careful. Oh, that one is -40 instead of 30. Okay. Oh, that one is negative. Which one? 20 instead of 15. How this thing stack, huh? I may want to. Okay, cancel. I want to do the next one over before I do that one, because well, it wouldn't matter. 30. No, because if the other one had a higher number than this, it will create an error and it's gonna break everything again. So, but it wasn't gonna break it regardless. So, but it's good to be cautious. 20. All right, go. Okay, roller is fixed. We now go back to the polar pattern. This face looks funny. All right, that's pretty good. We got the 5mm pin here as well, so that's also pretty good. And just hide the face now. Okay, only one way to find out for sure. To create the body of to sketch out the shape of the housing. And to do that, first and foremost, grab me a new body. Call that the housing. Yeah. Put a roller in as a reference point. Do we need to reference a roller? I do. For now, I will need to reference this. So yes, reference the roller for me. Yeah. Okay, so I can hide the roller now. And we need to grab the origin. I've never print TPU, but would it be possible to build something like this by gluing the outside TPU part to the inside part instead of going two-changer route? I know two-changer is cooler, but it is possible. I've seen it before. It's not at this. It depends on how big your part is. So with this roller, for example, trying to find one that I can just disassemble. The inner part, the inside cord, is too thin to be press fit in place. The inside cord was too thin to press fit in place for this roller that small, to be press fit in place. But technically, if I work with tolerance and all of that, I can eventually make it work. That is completely possible. It's yeah, it is possible. And if you got glue going on, if you got a lot of epoxy going on, you can also play around with gluing the hard bit onto a TPU housing instead of, you know, like two-changer in place. So yeah, it's not. There are multiple ways to do this, and honestly, the best way to make a mechanism wheel housing is not 3D printing. It's take a 2mm aluminum or steel sheet, cut it into the right shape, bend it to make the little tab that hold everything in place. That is the better way to do it. But I just want to play around with the 3D printer. That's all, and two-changer. So now we grab that. Yeah. Oh no, we don't want any. We don't want any beef here. We just grab that. Okay, so that'll be the dimension of. Wait. I got something. Can I have a project? Turn off that. All right, there we go. Yeah, cut away. Yeah, diameter here. Reference. Okay. It's not exactly true. Okay. It's not exactly true, but can I predetermine this hole? Take that a reference. So no, so the pin itself is 5 mil. Pin itself is 5 mil. So, but if I add, well, let's just say I want a 5 mil wall, so that whole thing need to be 15. Then we have a 5mm tire going, no, 4mm tire going on with that, right? So if I have 14 mil, oh, what multiple up? 0.4 plus 0.4 plus 0.4, 1.2, 1.6, 20, 2.4. So how many walls is this? I'm trying to say. 14, no, 7. 7 minus 2.5 divided by 0.4. That's 11 walls. And it is right now, it's 11. Okay. And I'm just gonna drop it one more down. Give myself a 6mm tire instead of 7 of the 5. Okay, so that's the shape of the outer rim here. Work through that on both sides. Symmetrical, and just now we're just gonna grab that there. Shit. What am I doing? Drawing like a caveman. Okay, I think we got something there. Okay. Oh, looking good, looking good. Rollers are all exposed with a decent amount of tire. Okay, so now we need to trim out the center. So let's knock that away. Center here. Now we go draw another again. Now this time we go 2 circle. First we need to grab that old one. Grab it. Turn it to construction. No, normal line. Let's see, and then in the middle we need a core. Not that big. Wait. How big is this? The roll-up area here. 22. At least 20, more than 22. But this one is already 40, I think, so it doesn't matter. Yeah, 30 something. Yes, 35. 35 is fine. 34. I think it's slightly small. Smaller than I expected. Once again, because the more I did that, the easier it is. Okay. Okay. So, both sides symmetrical. Okay. Okay. Maybe a little more actually. One more. No. Yeah. Okay, that's too many mil. Too much. One down. Right. So yeah, I just want this little edge here to be exposed, so we don't have to go down too close to that. All right. Save that. Now trim out. The what it called, the roller housing, roller design. Honestly, yeah, let's just grab a body of that. In the housing here, we shall add a body, add that body. Then we go cut it. Okay, like that. Look a lot better, isn't it? Okay. Yeah, this look a lot better. And in fact, if anything, I want this to be. I take it back on the giving it a little hinge here. The more material we have here, the better. How thick is this already? Dimension. Dimension. Oh, careful. Wait, did it work? 12. It's already 12 mils thick. Do I want it any thicker? Do I want it to be any thicker? If anything, I think I can shrink it inward a little more. So let me hide this binder here. 12 is pretty thick. Yeah, it's very thick. It's it's thick enough to cause problem with printing on a 3D printer, because the topmost layer here gonna pull the whole assembly into itself when it's cooled down, and then it's gonna warp the whole thing. So yeah, I agree. But the thing that I need to check now is between this point here and that face. So that is 5 or so. Okay, that's still too thick. Okay, so I reckon I can reduce the entire size of this thing. So that's this one here. So for this one here, I can reduce it by let's give it 3 on this side, so 6 in total. 30, so make it 86 or 82. So reduce the width between that point and that point there. That is. And yeah, no, leave it at this for now. Oh wait, there's a little gap here. Is that okay? Yeah, that's fine. I'm gonna bore it out more anyway. It poke through. No. So this little hinge is not there to be worried about. There's nothing to be worried about because I'm not even gonna use this roller as it is. This is just a template with a the only thing that is matter to this template here is the curvature that we have established and the number of roller. We'll deal with this rod later. The key here is actually the depth of this. It's 4 mil. 5 mil sleeve. All right. I know I lowered it about the. I lowered the what is it called? So about this website for a while, but I do wanna know. Oh wait, I'm trying to think here. The rod itself is 5 mil, so we don't want the bit of plastic that hold the rod in place to be what is it? Not as thick, right? So we may want to add a little one extra mil on each side here, just so that it can get to 5 mil. Is what I'm thinking. Yeah. Problem with not going with a 100 mil rod is that I'll show you later. Is because the one that I have in stock right now for the 5 mil rod are this 5 mil rod that I have in stock right now. Oh, so oh yeah, these are 5 mil aluminum rod, and yeah, I have to cut it anyway. I tried steel rod. Steel rod work well, but the problem with steel is that you have the good one is very expensive, and the bad one is very bendy and very curvy. That the come in the box already curved. So I bought aluminum instead because aluminum is easier to get them cheap for better quality, manufactured quality. Let's hope that's working. Okay, where was I? Yeah, where was I? Yeah, we were going here, and I were going for a increase. Oh no, get out of the measuring tool. I'm in the escape key a couple of times. We'll add 2 more mil here, so like that's this. That means 1 on each side to create that. And the unfortunate proof here is that I have to then board it again. Rid of that area. Alright, that origin. Okay, what I'm about to do is I need to because we don't want the wheels to touching this surface here. We need to build in some sort of buffer, right? So I need to try save it first. I need to try create a offset. How do I do that? I'm trying to look for something here. Yeah, let's just cut it. See where that go. Bomb radio. Can have a radio cut. Yeah, I just want that same shape, but then balloon it out for like a millimeter. So I might have just need to bore a hole here instead of doing a perfectly nice geometry. Yeah, no, I can't do that. All right. Offset. Yeah, no, I'm trying. There's no. I don't know. Does that exist? I swear that it exists in the other. Yeah, no, I know for a fact that it exists, and that option exists in every other CAD software that I use, but I don't know about this one. So here. Scale, fillet, chamfer. A lot of the time it's more of knowing if it is or not. Subtractive primitive, create, subtract. What the hell is that word? Let's script that. No clue. Cancel. Wait, in the Boolean option, is there an option for offset? No. Yeah, there are ways to do offset, but in 2D, not in 3D. So I can click on that. So the idea is just okay. Geometry, graph assembly, text drawing, cam surface. Where's this? Oh wait. Subtractive, center, primary contour. Both very useful and not useful at all. Torch, wedge. Option do we have? Additive, additive wedge. What's this one? Multiple transform, whole pattern. Yeah, I don't think it exists. Not in this specific workbench. Not in the way that I know. I'm on the wiki and said 3D offset. What is that talking about? Yes, yeah. Compound tool, offset. Alright, that's it. I'm joining the wiki too. FreeCAD 3D offset. Out, flashbang. Part up. 3D offset. Yeah, you can definitely tell. Yeah, you can definitely tell that there seems to be something here, something there. 3D offset, press 3D offset. Which version is this? Part offset. Oh, part offset. I think I know. I saw that somewhere. In part, yeah. Offset. True? No. No, I need to. Oh, there it is. Found it. Hey. Oh, wait. What did it just do? Crap. Cancel. Okay. Found it. What's this? 3D offset. Wait, why did it blow outward? Cancel. Uh-oh. I see what's going on. So it's gonna look a little funky for a while because I can't. Oh wait, no, 2D offset. Maybe 2D offset. Yeah, maybe 2D offset. 2D offset. Come on. 1 millimeter. Wait, no, cancel. Wait. It doesn't allow me to select a face. That's the key. Yeah, no, that's not it. Cancel. Now, so 3D offset, gonna plug up that hole. So I need to drill it out again. But I think -1, make it a -1. -1. Oh, 3D offset only for the whole part. Yeah, that's the problem. The whole part mean, so basically all I need right now is the bit in the middle here. I don't care about the rest. But the rest I can rebuild easily, right? So I can rebuild the rest easily. So I just need to put that in there for now. Also, why is it in a different thing? Anyway, so I can rebuild. Oops, so I just need to check. Why aren't you? Okay, hide that. Put that back on. There we go. Eh? Why did it not away, huh? I need to see that offset here. Why is it not? Oh, never mind. It broke. Okay, never mind. Okay. So took that housing off. Oh wait, Control Z. Yeah, take the offset off. Yeah, like that. So Boolean. Alright. So we're going to do 3D offset again. The offsetting again. Where it gone? What's this? Scale selected shape. Scale select shape. Wait a minute. Rid of that. No. Yeah. Get that one. Scale it up. Slightly. Where's scale? Uniformly by the factor of 1 point, that's 1 point, give it 10%, so 1.1. Ooh, here we go, we found it. Alright, so instead of 1.1, what I'm gonna do is I'm gonna give it 1.05, so 5%, right? Because 5% bigger in every direction. No, didn't work. Did not work. Okay, never mind. Yeah, because it's bigger, but not only in the size of the bearing, but also the entire thing. Okay, so close that. Josie, that didn't work. Yeah, circles not a command. Yeah, it do be like that sometimes. With this software. Compound tools. Yeah, only Y and Z. Yeah, maybe. Let's see. We do that. We scaled it non-uniformly. Let's see. Which one is this? Let me just figure out which one is what. So the going through is the Y, right? So only going for Y and Z. No, we have to go for X and Z. No. We can't do that. Close. What we can do is to delete this body. No, because the problem with that right now is because we are trying to we're trying to scale the a group of pins, right? So the relative position between them also got scaled up. So what if I just grab one of these? What if I grab one of these? Yeah, and I'll duplicate that. Come on. Yeah. Let's just get rid of that for now. For design, yeah. Have the groove here. Duplicate that. And I just hide that. Yeah. Can I just scale that one? Relative. Okay. And scale actual. Okay. Design scale. Wait, what's this one? Revolute, root, scale, non-uniform, shape. That's it. The thing that I want to do, cannot do anything. And we're gonna 5. I think that's not gonna work, but we're worth trying. Okay, so put the housing back. Yeah, no, it's still doing that. So this thing is not central. Why it's gonna blow up no matter what. Can I do actual? Cancel. Get rid of that. Let's see. I mean, it is useful command, but there are ways to do this better. They're different. Yeah, let me just do that one college. Give one last college a try here. Cut. Is that an actual cut? Give the machine. My printer is just finished, so I can test out the thing that I was testing in a minute. Right now, let me just get rid of that. Put the housing back on. Yeah. And yeah, we just cut it out and do it normally. Gonna think. All right. Roll it. Not too much thinking. One sec. Clone that. Housing, and a boolean. That body. Got it. Okay. Got it. Right. So that is the cut. Like that now. Okay, so we grab that face. Can we wrap it out? Yes. Flip. I wish there's a radio. Face normal. All to side. Cancel. Okay. Okay, this is not optimal. And what do we do? What are we gonna do? To grab that curve there. Oh, what do you have? This is a dodgy. Oh, this is a dodgy shape. Wait, why is it like that? Oh, I chose the wrong face, that's why. Okay, that close that. I don't know which face I chose. I need to go back here. Draw on that. And of course, yeah, that's the one. Cut away. Cut away again. Need to grab the best. Grab that. So that's going upward. And we grab that just to see what's going on. Oh man, this radio cut is so much more expensive than I thought. Oh wait, but then the center is the same, right? Oops. Oh god. Yeah. Remember what I said about the 45-degree things? It would be so much easier to design this around the 45-degree angle than 25. But it is what it is. It is what it is. This one, oh, it's a circle. The one is not a circle. What is that? That's a weird radio button. Wait. I'm overthinking this. Oh my god. Let's grab that. Because this is a circle, right? This is a circle. So I'm just make a distance here. Oh, not like that. Make a distance here. Hello? Hey, cat? Get rid of that, get rid of that. Yeah, yeah. Dimension. Come on. I don't know what's going on here, but yep, just give it a distance. Hello? When was the last time I saved again? Oh shit! Oh shit! Oh wait, no, that's fine. It's fine, it's fine, it's fine. Save first. Save. We can just have a taper extruded cut. Right? This section is a circle. It's just a circle. It's just a circle. So we just take that, make it 1 mil, like so. Okay, and then we cut it. Cut away. Reverse. Go up. Up. Come on. And the reason why we were trying to do the offset thing so much was because because that there, because the roller got bigger as we go upward from that surface. But what we could do is we could just taper it like that. Do it mid. We don't need any perfection here at all, I don't think. Right, so just yeah. Oh, alright, back now. Back down. And up. Up. Yeah, that's good enough. Alright, like that. Any thoughts? That looked good. Okay, so I will. The problem that the only thing with this is that I have to do it twice, 4 times. And there need to be 4 operations for all of this. So I'll take that one. Then I need to revolve it around the x-axis. The y-axis for 6 times. Yeah, like that. One side. So that's first operation. Second operation on this side. So it's not impossible. It just you know, it would be so much cooler if I could do the other thing. All right. Bum. Dimension 1 mil. It was 1 mil, right? What I did before? Just checking. Yeah, 1 mil. Okay. I want to take that. We extrude it. And I totally forgot the parameters that I use. Right. 12. This is 12, I know that. This is like 8, I think. 9. Yeah. Second. Wait, why did it cut? No, it didn't cut. This guy here. 10. Cancel. So it's 10 degrees. Okay, take that. Rotate it. Y-axis 6 times. Okay. And voila. Roller should now have a 1 millimeter gap. Ish. Not perfect. And in fact, I need to the whole face downward millimeter. No, I will push the roller inward 1 millimeter. Should I? No, the whole face go downward. 1 millimeter. I think no. Well, I wouldn't say 1. I say 0.5 mil. Oh wait. Crap. Oh wait, no. What I can do? What an idiot. what I can do is I can just tap double direction here. Direction, two direction. Yeah, that's the one. Two direction. This is 1.5. 5, negative 10. Is it negative 10 or taper angle? Oh no, it's negative 10, yeah. There we go. So we don't have a new operation for this. Okay. Look at that bad boy. Yes, I did that like so. Wait, what's that? What's that? Ah, it's up there. Okay. Two direction. Put 0.5. Oh, 0.5. 5. Negative 10. Okay. Perfect. Wait. What happened there? What happened? Oop, my bad. I got it. Oop, I got it upside down. I got it upside down. Reverse. Nope. Okay, so this is a 10. This is a 10, and this is a negative 10. Huh, okay. Like that. Hey! Again? Oh. We may need to push this out 1 millimeter. Okay. The wheel is getting bigger. But all is good. Still. All is good. Save it. Alright, let's check up the bed. Make it safe, right? We're going on this camp right now. Getting on the bed here. That's just literally just a flat surface, so that I don't expect this to go wrong at all. Ow. Melt of this thing. Smell of freshly melted filament. Now smell like cancer. Let's hope that's not proven true in 20 years time. Be so cooked if that's the case. Probably I want some children before I did something stupid, right? Making sure that the the equipment is working. Nothing is passed down if I do something stupid to myself. Oh wow, this thing so good at carving things out. Yeah, that line is there for good. Alright. This one is supposed to go on like that. From this side here. So this will be partly be responsible for keeping these two pieces together. Alright. So these two pieces here have holes on them. We'll just put this on to mount them all together. And I think it just worked. It worked just fine. I am concerned. Yeah, I am concerned about the air tightness. The how much airtight do we get out of this though? But I can always fill the thing in with some silicone if needed. So yeah, I'm happy with that. Happy with that. Okay, you can definitely see that there's some gap between there. You can see some gap. I don't think you catch on camera, but there's a gap between there. Come on, there we go. See, there's a gap right there. So air would leak past from one side to the other, to bypass the carbon basket from the top. Yeah, so I'm gonna have to go and find myself some silicone, some like silicone that they use to seal in like Oh, what it called? The silicone that they put on the wall for ceiling, right? Grab some of those later. And should be all over the place. So, okay, back to this contraption. Okay, so where are we going with this? So this is not printable as this is right now. So what I'm gonna need to do is I need to cut it in two, one in the middle. What I want to do right now, though, is see how much material am I looking at. It usually doesn't hit you until you actually put it on a build plate, and sometimes even more than that. Oh, reference, yeah, great, yeah, that's good. What's that? Alright, this is a 35 by 350 by 350 build plate here. Wrong file. What is this bringing? But there's definitely something up with this material. But never mind. No support needed. I just need to see how much material that this is gonna cost me. Let's see. 100 gram. You guys don't see it, but it's 100 gram in this entire column. Not bad, not bad. So for a kilo, oh sorry, this entire column here is 100 gram. That is to say, if obviously later I need to chop this into so that I don't have to print any support for it. But a kilo of TPU 95A would allow me to print out 10 of these. Which is great. This is getting together really well, huh? Can't believe I actually make it to this far even. Okay. So that is the housing design. Housing designer. Oh, there's the designer with the D. Follow the naming scheme here. Yeah. Like that. Now we need to make it printable. Wait, no. I need to figure out what to do with this hole. 5mm hole, or I don't think the hole need to have the pin. The pin don't have to rotate around the hole, doesn't it? Pin doesn't have to rotate around the hole. In fact, so anyway, so yeah, so let's just keep it at that. So keep it at that. Now we grab that whole design here. We create a clone of it. That body now is now call it the let's call it left and right. What left and what's right? No, there's an inner one and then the outer one. Yeah. outer body first. Outer body. Outer. Housing outer. Housing outer. The outer is the one that face inward. Inward. No. The outer body is where the other bolt came in from, and the inner body is where the gear is. So there will be a little gear right here in the corner here. Grab myself this face here, draw on it. This one simply need to take a giant circle here. Got it. Reverse. Now, yeah, I make this one the outer body. There's no right or wrong here, just, you know. And for the holes, we're gonna grab it from down here. We're gonna draw from that bottom. Yep. Then we need to take into account of this side, the side of this ring here. There's that. Whoop. Oh, let's just draw it. M5 bolt. 3, 5, 4, 2. How many M5 bolt do I want? 2 is enough. 2 is enough. No, we'll make hole for 4, but then we'll put 2 on there. Just in case, you know. Right, the head of the 5. Oh. The head of a 5 M5. Ah, this thing doesn't come off easily. Oh my god. Electric screwdriver. Oh yeah, this is why. No, this thing is why I bought this thing in the first place. Oh look, it's ripped in the cloth. It's not coming off. Oh, there it is. Open. Alright, M5. What's the size of this thing? This is an M5, yes, but how long? M5 by 80. Oh, quite long. Alright, make sure that the torque came down. Alright, and the reason why I got this now is I need to see how big the bolt head is. The head on this bolt is 8.3. So we round it up to 8.5. Dimension 5. Oh wow, that's huge. Dimension. And bottom 4 equal into that line with the P, the tension. Like so. And now those holes will mark the center of my hole, the center. So I can use this function here. This is the hole function. Isometric M5 counterboard. No, I don't have space. Diameter. No, where's head diameter? Head diameter is 10. Oh wow. Oh wow, they actually give me a lot more than I need. But that's good enough. That's good. That's good. Yeah, and then I just go through all. Like that. Yeah, I need to check the side of this wall. The wall doesn't matter too much. It's always a torsion. So basically, it twists against each other. So it's more of the distance between these two. The plastic between these two holes that bear the weight of this. The rod going through it all is, let's see, 6 millimeter. Oh, let's see. It's not a rod. This is a bearing. The bearing, that's that hole in the middle gonna tell me how thick the rod is. 8. It's an 8mm rod. Of course, now that I read the label, I know it's 8mm. So we got an 8mm rod going through as a truss for this thing. Oh, oh crap! Do you have 24mm here? 22mm here? One more. Let me try this again. Like this. Oh, 20. Ooh. Uh-oh. That's not good. Oh, you're back. Yes, I found a way out. One sec. I need to move. Yeah. Alright, I'll show you what I did. So, I cannot offset the face. That complex geometry that we use, I cannot offset it nicely. But what I can do is do a paper cut. So I'm gonna go here. There we go. See? So I just take the same cut, but I taper it out at 10 degree up and down like this. So it bored out just enough material that I would say about 1 millimeter. So we won't be able to reserve the shape, the geometry nicely, but we at least got a gap, a sizable gap. But yeah, that's the idea. Now my next dilemma is in fact with this now. Oh, actually, I don't fix it here. I don't fix it here. I fix it here. Huh? How much glitter did you put there? 1 mil for now. I'm good. 1 mil between this face here and the roller. It's 1 mil is very small. I do admit that for row work, it's actually really small. I do want to see if I need to give it more, because the more I take off of this face, the more I have, because this is at an angle, right? So the more I took off on radially, it will dig into this surface as well. So this one had already been made 1 millimeter more, and than before. So let me just toggle transparent here. Yeah, this gap between that where that bottom is and that face is worrying me. For now, let's just stay with that. The rendering. So I want to be what because if we put a very large torrent in there, it will work for sure. But then we're like, okay, but how low can we go, right? So I want to try with the more optimistic one first, and then we'll print it out, test it, and if it works, then great. And if not, we can always increase it. We can always make it worse, harder. Anyway, what am I doing? Yes, I was going to bore out the hole here. This one there. This one. So I wanna put the binder back on. Oh, right, I got plenty. Give it 2 more mil. Because I don't have enough space to put the what it called. No, I do have enough space. I just need a little creative actually. Make it 35 first. Take it away. Alright, take that away. Yeah, so if this bolt pattern here, like that, red travel starts toggle. Yeah, so this hole for the M5 bolt coming through is infringing on the size of the available space for the 22 millimeter roller skate bearing that I have here. So we need to cut it out. So we need to make the space bigger. Yeah, H22 external. Yeah. So I need. Let me just draw it out now. 22 mil external. Actually, let's put it 0.5 because this is a 3D printer. So what's gonna happen is that it's gonna shrink slightly. How wide is the actual of the skateboard? The size of my foot. No, so basically you mean the whole rod that connect the 2 wheels, right? I don't have a number yet. I'll say 250, 240, maybe 240. It will depend on the size of the board the deck that I'm gonna use, whichever I wish I have not found yet. Oh, the diameter, the diameter of the axle. Yeah. The standard number is 8. So standard skateboard axle rod is first of all, make up steel. Second of all, it's made out. It's 8 millimeter. The only thing that is different from what I have right now is I am using stainless steel, and they usually use mild steel for those things, for the traditional skateboard. So we'll see if stainless can do the trick. What am I doing? Don't need to do that. I don't need to do that. I mean, that should be fine. It's not that much low. A mil rod are strong for shear force. Yeah. It's a pain to cut as well. No, I'm trying to cut. This is my bedroom. The floor is carpet. You don't see it. The floor is carpet, so I cannot have any power tool in here. So have anyone ever tried cutting a stainless steel rod with a hand tool? It is doable. It is doable. Yeah, I know. Stainless steel versus mild steel, you mean? Yeah, I know. It is doable trying to cut stainless steel with a handsaw, like one of these. Right? Oh no, oh, it is doable. And you only need to do it. Oh, you only need to do it twice, right? You only need to do it twice to cut 2 rods. It's doable. I swear. Oh damn. And I'm not looking forward to it. I'm honestly not looking forward to it. But yes, it's obnoxiously hard, that one. Diamond, actually, 5.2. Yeah, make that tangent to that. So basically just a normal M5 with a bit of extra room. I don't know what that 0.2 may or may not cause some trouble later. Okay, that's good. That's good. Okay, so now to sketch here, we shall. Alright, 22 dimension. Now, this is the part where, oh wait, no, I don't. It's go down by 7 mil plus whatever this thickness is. So what I'm doing, because what I'm going to do is I'm going to use the head of the bolt, M5 bolt, to hold the bearing down. Well, so I'm gonna, oh, not 22, sorry, 22.5. What if you put the bolt inside the middle thread and into the nut? What if you put the bolt in the middle, thread it into the nut stung into the other part, and put the bearing on the outside? In the middle, the bolt in the middle, yeah. Thread it into the nut in the other part, put the bearing on the outside. Ah, I see what you mean. I want the bearing on both sides of this half. At least on both sides. Right? So I think what you mean is that if I put the nut in the middle here, right? Go through and connect to the rod, which is there's some sort of stop on this side that just allows it to screw it this half into that half with a bolt in the middle. Yes, I can do that. But what I want to do is that because that means the necessity for the bearing to be just on this side. But what I want is I want the truss to go through this entire wheel from both sides and have one bearing here and one bearing here. One bearing here, one bearing here. Like nut bearing, nut bolt bearing. Bearing, nut, bolt. Bearing, nut. Oh, I see. Because the bolt on the outside of the bearing won't fit. Both bearing, nut, bolt, bearing. No, the bolt on both sides. No, both sides. Bearing on both sides. Bearing, nut. I don't get it. One sec. No, because the bolt on both sides, on the outside of the bearing won't fit. It says something about having the Wait, you saying that we use a 8mm bearing on our bolt to use that as a shaft? Anyway, let me just finish what I'm doing first as well while you take your time to respond. Alright, actually it will fit. It will fit. So the bolt header here is gonna be like that. And up to face, sorry. To face or to that face. Then we downed it by 7 mil, 7.5 mil. That. Wait, how big is this hole? 2.75, 2.75 times 2, 5.5. Oh. Yeah, no, it's fine for me. Yeah, it works fine. So now the bearing can be press fit all the way in there. And then when the bolt come in, and it will just line on top. The heading will just line on top and it hold the bearing down. Oh, this is angle. Oh, if it fitted better this way. Yeah, okay, good. All right. We shall punch a hole. Yeah, we punch a hole through here, and this one got to be 9 mil instead of 8. I don't want the rod to be rubbing against this hole at all. I want as much as possible, clear as possible. What's that happen? I'll cut it through all. That bit through all. All right. Trying to think here. Do I want a bearing in the middle? No, I don't. No, so one of the things that I did with this one, if I can take it apart now, actually. Okay, I cannot take it apart. No, never mind. I put a bearing. So basically, I use a bearing to join them together. So I cut half the bearing worth of inset here, and I have half the bearing worth of stuff on the other side, so that the bearing would sit in between them and join these two groove together. The idea was that back then was that that bearing will like be in place of where the two the exit and entry of these two have to come in, which could have rubbed against the body of the rod and cause friction. But then now that I look at it and realize that that's just extra thing that can like cause intolerant friction, right? So if the bearing is offset with each other too much, it will then cause problem later. So less bearing is better. Less is more. Less is more here. I am worried, however, about these holes here. So let's just the key problem with now is that what stopped the the pin to go all the way through. So I need to put a stopper here, or else like the vibration can push the rod eventually go through right here, right? Even if you press fit it perfectly the first when you first put it together. Okay, yep. No, I'm just playing around. Don't worry. Let's see. How do we do this though? All right, one second. Okay, let's grab that. Put a tandem plane on it. Put a tandem plane on it. So it would be parallel to that, like the spin on the bushing you were talking about. Oh yeah, so if it fit better that way, so the rod are spinning on this and that the rod are spinning, so the rod are spinning or stand still. The rod is still. The rod is structural. I don't want the rod to move. This whole assembly gonna spin around the rod. That the bearing is there to hold it, to make sure that the plastic doesn't rub against the rod, because the bearing, the plastic rubbing against the rod is the worst thing that could happen. It creates too much friction. So the plastic probably get weared out extremely quickly. Do I want to do it here, or do I want to do it in the other assembly? No, I mean the rod in the small wheel. What? But make it more sense to have them still. Oh, you mean? Oh wait, not in the smaller wheel. No, the rod. Yeah, the rod is also still. Yes, the rod in the roller. Yeah, yeah, the rod into the roller is also still. How do I do this? I basically want to cap this hold off. Yeah, no. So I'll show you what's causing me to be worried about it in a second. Actually, let's just show it now. Let's just do it now and I'll show you. Oh my god. Okay. Oh, what should happen? Why? And it crashed. FreeCAD. Yeah, no, it's a memory problem. I already count that bug for like several times. I'm not doing that again. But yeah, FreeCAD 1.1 and memory leakage, and also my computer with the lack of memory. So like if multiple things work together to make it harder. Close that. I cannot imagine, right? It's hard to imagine nowadays that 16 is actually not enough. Now, because this point here, this surface here is touching the edge of this face right there. Right, that's right there. There's a point here that's touching, so there is a chance that I cannot cut to face. Yeah, I cannot create, make these two touch each other. No, I cannot extrude this circle to this face because that is already touching there. What I have to do, see, first of all, I need to see what I'm doing first. I need to drag this down by a fraction of a millimeter. All right, that's 1 mil, so I need 0.1. I don't. Oh, negative 0.1. My bad. Negative 0. Yep. All right, then redraw this by just click on it and close it again. Now I can do this up to face that one. So that's how we close the hole. Okay, so now grab that padding, rotate it, spacing. Wait, what? Select reference. Can I select that? Hello? Select reference. Oh, no. Let's just go for basics. Y. You go for the Y. There we go. Easy enough. Alright, close the hold off. We'll think about that. Wait. Yeah, it's fine. It's fine. I was thinking about making this looking good, like chamfer it, make it like flare out a little bit, but then it's like it's a prototype. I'm not right now. Not right now. And yeah, I do. We'll clean it up, make it look good later. Okay, so what I'm doing now, so oh wait, no, one more thing. We need to chamfer that. Because was it this transition between the flat to that power there is not great for forced transmission. Low transmission transmission, yeah. Where is it? There. Where it gone? Wait, did I not have? Oh, I didn't have it. Okay. Reload design. Okay, that's gonna be a little bit tough to look at. Actually, let me random color. Give it a bit of color here so that I can see. Yeah, there you go. There's a gap here I can see. Oh. We're not gonna touch it. No, I want to go as far as I can. Oh, Stanford actually helped ton with 3D printing. With the metal, it's mainly cosmetic, but for 3D printing, it's helped a lot with the preventing layer from splitting in an artificial artifact around the corner. Yeah, that's for sure. I'm gonna make it 5 mil. Wait, did I chamfer? Yeah. Alright, this now. Good. Yeah, that's alright. That's alright. Alright. Okay, say flat. And now we need to do roughly the same thing, but on the other side. We hide that way. Open. Make a clone of this whole body here. Now set. Oh, so it's housing outer. Now cap lock. That was a amulet. Ah, yeah. The pros and cons of living right next to a hospital. Done. 120. Okay, which direction am I cutting? That direction. Oops, sorry. Grab that. Oh. Really, let pocket rule. It's not necessary, but in case in the future, I don't think I'm ever gonna extend it beyond 721 on each side, but that's good practice for this moment. You cut through everything. And now, oh wait, actually, okay, now we go and grab the other half as a reference. I'm just pondering, that's all. Yeah, so that we can see what's going on over there. Not necessarily. Oh, I do need it. I do need it. I need this hole here to drill through. Right, one after. There we go. Now what we're gonna do is we'll select that face, draw on it. Then we should expose the binder again, cut away so I can see what I'm looking at. I'm gonna grab the hole. Cool. Cool. Okay. Now there will be a gear at the other end. There will be a gear at the other end, like that one. So the gear is what gonna carry the threaded insert instead of this assembly. That's half of the assembly. Oh, speaking of which, I should have drill out the hole in the middle too. Get this one too. Okay, so now we're on this side. We need to put a bearing on here. Drawing. I need. Do I need to do that? No, I don't want to do that. The size of the bearing is fixed. I don't play with it, and also I don't want to reference the other one too much, because in case I change it too much, and then this one gonna knock on effect and all of that. 2.5, and don't worry about the interference here. That's just because the hole is these holes are 5.5 millimeter bigger than it should be, so that the bolt can come through nicely. Let's go down 7.5. Oh, not 7, 0.7. Okay. And oh yeah, and I need to close this gap here. Close this gap and then a chamfer. That's it. Ah, oh, damn it. That's not great. So what happening here is that the line that I was relying on to select the edge here is not available here. It's this line here, but this line here is on the tip instead of where a drop. Okay, trying to think here. We can just grab that size, put it down the plane to it, and then we drag it downward, as close as to that as possible, close to that little line there. It's not that important, so. And also that the other one I also drop it down by 0.1 anyway. Right on that, draw on it. Also, why is the planes over there, not there? Oh. It's this one. Turn that to the normal line. Yeah, extrude it. This. Hey. Try the plane as well. Don't need to see that too often. That. Rotate it. In the Y axis. 6 times. So. Save it. Really should have do some exercising before in the middle of all this. Alright, sham for that. Now I noticed something a minute ago, and this may or may not cause something to break. A minute. Should have thought of that. Yeah, so this surface is going to be printed on this face down here, like so. So this thing in the middle is an overhang. It's not great for trying to have a circular overhang on a 3D printer, because now the printer gonna draw a circle in mid-air, and software the machine won't do that very well. So we will have to counter it, yeah, with some work, yeah. What's the best way to do it? What I'm trying to think here, sometimes. I just draw a rectangle around it. No, not a rectangle. Sorry, a square around it. Yeah, we can just draw a square. Let's draw a square. The problem here is this one. Now the reason why it may be breaking because of this one here. I reference the entire object. It will look fine with support, yes, but this is just me being pedantic about 3D design for 3D printing. And also, remember, this is going to need to be printed out in TPU, right? TPU support. Have anyone ever tried to remove TPU support? You know how painful it is. With that said, I'm designing with the premise of using this one tool changer, didn't I? Yes, the oh no, not the entire thing, not the entire thing. No, there will like the best way to show it is to just import it into the tool changer to the slicer. Import this. I just reload the file browser here so I can get my auto design. Yeah. And I to change this to my multi MC1 multi. All right. So what color are we using? Yellow and oh, man of culture, Bruiser slicer. To be honest, I actively trying to not get attached to anything in terms of like provided by companies, right? And Prusa slicer, the only reason why I'm using it right now because my material profile is going. So if I want to try to transfer all of this to a new slicer like Oka slicer, it's gonna be a long day. It would be a long day. So that's why I'm here. And also, why was I here in the first place? Tool changer. Prusa is the, well, even to this day, they are the only people who actually invest in the slicers to the slicer of tool changer. Everything that is new in terms for tool changer is basically new. Is come to the Prusa slicer first and foremost, then it trickle down to the other slicer, including bamboo, including Oka, about a year or two later. Funny part is there's a lot of like in demand feature that a lot of people are asking for, and yeah, it's not gonna disappear. It just take years. It's gonna take years. It's not gonna no. So the way that yeah, I know where the file is. I know it's the format of the file that changed between the slicer. So Oka use a JSON config to save their material profile, and well, their profiles is like any profile. They use JSON. Prusa, they use an int, so init file, and it's not impossible to work with, but it's still a long day and it's annoying to transfer them over. So I'm just like, I'll do it some other point. I even download Oka at some point, then I deleted it because it was messing with the Pop OS. So where was I with this? Yes. So let's change the color to something dark here. So let's go for blue for. Let's make blue the color of the TPU, right? The rest of them is whatever material that I want to use as structural. So smart here, smart fill. So where do we want the hard stuff? Where do you want the hard material to be? I say no. Let's just stop. No, let's go with the TPU. The TPU is easy. The TPU is definitely on the outside for one. It's just protected from being crushed, right? So if we slice it now, I'll show you. Because it's not, I'll slice it now. Wow, so it's taking so long. There we go. Ignore the white tower. I don't care about that. Yeah, you see how it penetrate the part there? That's what I want for one. Two, there might be other places that you might want TPU as well, just in case. Right? So no, so the reason why I want a TPU outside there, that's for sure, because CPU, because that is the toughest place to be. That's a tough place. The outside is a tough place where TPU may be helpful. But also, if we have TPU in the center, because TPU had low coefficient of shock absorber, right? So the pins going through these holes, right? And because they are going through those holes, when they are flexing on it, material that is less likely to deform within that hole is TPU. So we may want to paint these in TPU. So I'm just going through the process here, just trying to point out what may end up in TPU and how it affect everything. Or like I'm trying to remind myself what I was thinking. Right, so I slide that again. And bada bing, bada boom. Actually, let me, okay, it's fine, we don't need it. All right, there we go. So you can control it down there. Now here's the problem. Yeah, internal shock absorber, exactly. Yeah, so, but the problem is that you can see here, this point, does the hard shell mean anything anymore? Yeah. Actually, it does. Yeah, no. Actually, no. Actually, good. That's good. This is good. This is perfect. So, does anyone here know about the katana? the sword, right? So the way that the Japanese did it, because they don't have that much hard metal, they had to put a thin the metal, the hardened steel metal, the hardened steel where it counts, then surrounded by the soft stuff. So hard on the inside, soft on the outside. So the hard part gonna do hard bit like just keep the structural stiff, being stiff, and the edge hard. But the soft stuff is there so that it can flex and absorb the shock when needed. So what I'm seeing here right now, what I spy with my little eye here is that, ooh, hello, that is that if I put the outside bit, including this side here, TPU, so all of this is gonna be like a giant shock absorber, yeah, like it, for this whole thing, while the inside core, the stiff hard stuff is still inside, keeping everything structurally sound. So that's what I'm trying to get at. I don't think that katana reference was making any sense. But I'm worrying is that this boundary between them right there and this hole here, that's what worrying me. But only one way to find out. And for that, what material does this orange stuff supposed to be is still a mystery to me, because TPU, annoyingly, TPU is one of those materials that is extremely hard to combine with everything else because they have such a low melting temperature. So if I cannot combine TPU with ABS, for example, because a chamber that is required for ABS printing cannot fit with TPU because it's like 40 Celsius for a chamber that is suitable for ABS printing. It will cause TPU to melt within the PDAV tube that guided it to the tool head. So that is a no-go. So I will need to I'm thinking about PCTG, not PETG, PCTG. So it's not a variant of PET that's softer than PETG. It's softer than PETG but more impact resistant. So that's what I'm trying to. TPU melt like 180 at the extruder, right? Depends. TPU is extremely versatile. So the one that I have, 210. Okay. Yeah, it's versatile. It's it's the softening temperature. It's the glass transition temperature that matter. So imagine the TPU getting clocked. Heat creep. If you remember, heat creep on PLA, for example, it's the temperature that TPUs have the same heat creep temperature as PLA at 40 Celsius. Actually, a bit lower than that, but close enough. So the heat creep temperature is annoying to deal with. So that's why TPU cannot be combined with high temp material, even if it may or may not help a lot, fortunately. So yeah. So anyway, this is what I look like, and I am going. These two material need to be, let's see, yeah, they need to be reasonably adhesive to each other, because you can see that. Oh wait, no. Okay, never mind. There's a little leg in there that's gonna mechanically latch them together. That's good. That's good. So that's how I'm gonna look. It's gonna look. Okay. Oh wow, I'm actually done. What time is it? 6.5 hours. Oh god. The annoying thing about this project here, the mechanism wheel project, is that once again, it's all dependent on that motherfucker there. Not that one. That one. That's the one that I'm gonna use to print TPU on, because that's the one with the extruder that is good enough for this. I need to get it finished. Yeah. So to get that done, what I need is to do what I was printing on a minute ago, which is, let me open. Yeah, now this is the part where I remind myself why nobody want to sponsor me at all, because I am building project on top. The project that this project right now with the mechanism wheel is The left one is the Trident. Yeah, the left one is Trident. The right one is the 2.4. The reason why the 2.4... Oh, I can show you this. So, looking good, right? Looking good. Looking good, right? Wait, I'm just it's not as straightforward as it looks. So first, what I do is I'm still in here. I'm gonna shut it down. Watch this. I think you're new, so you haven't seen this, so I'm gonna do this in here. Right? Okay, watch this. Okay, so it's shut down. So I'm gonna go to the machine, shut it down on the source. Fortunately, this power. Oh, sorry. I unplugged the camera. I need to plug it back in. One second. All right. So one downside of this is that 24 volt cannot be a hot plug. So I have to shut it down right there. Bum bum. I'm gonna put 1, 2 on, and not put all of them on. Wait, which one is which? Ah, shite. I know which one is which. That's not it. Need to put that one on. Not gonna connect the PDFP tube. Kind of annoying. And voila! Gonna give it a second. It's gonna boot back up. There. Wait, no power. No power's on. All right. So while it's booting up, here transition, art and canvas. Half of it are. The two on the left are. The two on the right is USB. So when I was developing this, there was a bit of a no. When I was developing this 2 years ago. Yeah, when I was developing this 2 years ago, there was only CAN bus at the beginning. Halfway through, the USB ports start coming out. That's why the two on the right is the CAN bus. No, it's USB, while the two on the left is CAN bus. USB is more stable than you heard. Back to the USB and CAN bus in a second, but I need to show up to what you can do. Right, so I'm just checking here. There is a config there. That's good. So what I'm doing here, because as you can see, because right now, if I physically plug the two head in, it does not detect it because normally you have to go through the config file and set it all up and all of that, right? For me, I just need to go in here. I go, all right, I need config number 1000. Bada bing, bada boom. Reboot itself. And voila, I got a dual two head system. All ready to go. Okay, there we go. Yep. Oh, mic set. Yep. Thank you. Okay. All right. So yeah. So what? Let me home and do the two chain here. That's so simple. Yes. kind of quite proud of, but it's actually easier than I thought to put that feature together. But anyway, CAN bus versus USB. USB is more like, it's like the Apple of the connectivity world. You work with what you got, regardless. So what happened is, in a CAN bus system, if you're like, if it's too long, or if the line is dodgy, like if the line is dodgy, if there's some sort of insulation failure and all of that, you can actually go into the config setting, tell it to go like, hey, this the current bandwidth is not that high as I thought, lower it down, and you can do that, and it will function very well because of that. USB, if something wrong with the cable or something like that, if it's gone, then it's gone. You can't fix it. You just have to replace whatever hardware is there to get it back. The reason why that matters is because of a heated chamber. Okay? So if this chamber here, with that, especially with that thing on the top, at the Nevermore Stealth Max, this chamber go up to like 70 degrees Celsius. You don't want to hit 70s because it starts melting the ABS within the chamber. But if you hit 70, if you get close to 70, what's gonna happen is that USB 2 headboard, no, every 2 headboard will start throttling in terms of like the processing speed on it. And USB 2 headboard, they're just gonna drop out. You can't do anything about it. Gone. That's why right, normally I just usually have two head on mounted right there, because once again, this thing can go 70 Celsius, and the moment it hit there for a long period of time, I will lose the print because the clipper got shut down because it lost the USB 2 headboard. And the CAN bus, what I did to the CAN bus that I just deliberately go in the config setting, and I told it to run at half speed all the time, which is still fine because the data, the bandwidth that we need for the tool changer is not that much. So CAN bus work just fine, high temp. But USB is, but the benefit of USB is ease of use. So if I go there, go quick tool change that. Hope it's still working. Oh, it's dead. Nope, forgot. The dock need to be. I'm not. Yeah, you can imagine the tool chain happening. I'm not doing that again. Yeah, because I forgot to drop the dock down where it's supposed to be to receive the tool head. So it fell. You can tell. But yeah, there's two heads there. Anyway, what makes USB special is actually over here. If you go to device, USB, refresh, that is every USB device on this system. So technically you can just grab this number here, I think. Copy that. I haven't done this in a while. So T2 for example is a USB item, so you need this part here. Okay, so device, USB, refresh. So yeah, you can grab something like this and just chuck it in there, and that's all gonna work. It's much more seamless to set it up. You don't even need to go into SSH this thing and get it all working, assuming that you got the right firmware. So yeah, that's what the power that is. USB more convenient, CAN is more malleable, so more adaptable. But yeah, let's be real now. Who the hell want to no. Most of the time, people don't need 70 Celsius to a chamber, and those who do usually have a different solution than CAN bus and USB. They're just gonna hotwire every item instead of put a chip in it. Oh, so are you using a twisted pair from a Cat 6 or something? Nah, I'm just using raw dot a bunch of wire. But to be fair, they went out of the box. They give you a cable, and that cable worked fine. So that's what I did. But anyway, let's try that again. Now that we have the chance. Oh man, I'm getting close to what it's called, finishing the design, and I'm feeling it. Feel it. The design of wait, what's that about this here? Oh, not nozzle cleaner. No, not this one. Not this one. Oops. Not that one. Wrong page. Wrong page. It is where gone? ACTM. Yeah. Load it. Come on. This thing here. I need to finish this thing before I can get on with the mechanism wheel. Oh, almost there. Almost there. Ah. Dun, dun, dun. All right. Let's return with a vengeance here on this guy. Oh, for can you can. Oh wait, I can heard it's very stingy with the cable you use, how it crimp and terminate. But I guess you can just lower the band baud rate and you'll find. Yep, that's the idea. Was it? Twist. You can make your own twisted this pair. The length of cable that you need is not much at all. It's like 1.5 meter. 1.5 meter. So a twisted pair with a you just, if you have 2 wires, just twist it together. Pretty easy. Remember, this thing can work to like was designed to work with kilometers in terms of like the length of the network. So few meter here, so like ain't gonna change much. Both that's go for both USB and oh wait, no, the USB goes 5 meter. CAN can go up to several kilometers if they needed to. Okay, Richard. All right. Turn up. Let's see if this works, because it's been a while. Let me see if I can. This can still do 2 change. You need to check. Need to remind myself that this is 2 changer. Hey, there we go. Yeah, very cool stuff. Yeah, I worked in a factory that built CAD and Ethernet. I've worked in a CAD factory. Yeah, Internet industrial step motor. Yo, that sounds cool. Was it CAN bus? The kind of thing that it's like, it's great if you have someone else to set it up and deal with it for you. USB is just more convenient if you are the one who have to do it all. Alright, but that's it for me, to be honest. So for this, once again, this is the main project at the moment. I need to finish this before I can get on with the system. More specifically, I want to put it into this thing here, into the Trident, so that I can actually print out the wheels via that machine. I don't trust the 2.4 for the 2 changer. I know I just demonstrated, but it's not reliable enough for me. So yeah, so I need to build this, put it in there, get it up and running, and start building the wheels from that machine. And the reason why I cannot just do it now, even though I do have that 2 changer up and running already, is because I am allergic to PETG fume. Right, so whatever the op gas that the PETG produce, what would cause normal people a little scratchy in the throat will cause me start coughing blood. So I cannot function without that filter. USB would be cool if you could use PD to power the hard end. Yeah, 1 USB circle and you done. You can get 24 240 watt and like 52 volt from it. It's less as useful as you think. No. So what I'm saying is, the way that it's implemented right now, and it is because right now what is going on with the USB is the data wires is USB, yes, but the power wire got swapped out for 24 volt. So basically, technically, you can in fact already can transfer you can already transfer up to 200 watt. Oh no, the 200 watt is the limit of the 200 watt is the limit of the PSU to the nozzle if I wanted to. So yeah, USB PD and no, PD and USB-C and all of that is a standard, right? It's not, but if you already have your own implementation, it doesn't you don't need it, right? I do appreciate the extra. Well, no, what would you need the extra headroom for? I mean, if there USB board that support USB power, you could do that from one cable. No, that's the thing. We're already doing that from one cable, right? It's not. It's right. That okay. Show it here. Yeah. Are you on this screen? Yeah. You on this? Yeah. That there, you see, is a single cable coming down. That cable is provided by the manufacturer. There's only 4 wire coming off it. Power in, positive, negative, data in, data out. So technically we already one cable this. That's fine. It's the connector that is not the same as the off the shelf stuff. Oh. Yeah. So we don't need to follow. We don't need to follow the industry there. We don't need to standardize that. If USB PD or USB-C and USB-C and the power delivery standard do more than just deliver the power. It's communication as well, because they are the host provide the power provider and the device need to talk to each other to know how much it can take and how much it can provide and all of that. That's why it's a standard and it's required like 12 wire or something. But here in the context of what we're doing, we already know that we know for sure what kind of power being sent, what kind of voltage is at the source, right? That 24 volt. We're not changing that. And data is not. We don't need that much data at all. So the 48 megabyte, 480 megabyte data rate of USB 2 is good enough. So we just need to choose up to USB 2, and that's all we need. Right, well, so where was I? Yes. I think that's enough for me. That's enough for me. What I'm saying now. Actually, now that you guys are on that phase, though, let us do that one as well. So you saw the V1 do the 2 change, right? Let's show V2 here. Oh no, never mind. Okay, never mind. Need to reboot the machine. If you leave the Raspberry Pi out for too long, it go to sleep and it shut the Wi-Fi down, so I can't log into it right now. Never mind. With that said, all right, guys, that is enough for me. Fabrizi. Yeah, god damn it. Thanks for joining me. Help me bantering with myself. No, I often just talk to myself half the time, so you just bouncing idea off me is really cool. Thank you for joining me, and honestly, I think not sure. Okay, I'm not gonna be streaming anymore this week because normally I stream on the Saturday, but for this week, because I'm going away this weekend, so I stream now. For the rest of this week, of course, during the week, it's on and off depending on the mood and how much load I have on my day job. But with that said, even now we don't have anything to stream with, because not to do in a stream at all, because the thing that I'm building right now is gonna take a few days to finish. So that's it for me. Thanks you all for joining, and yeah, I'll see you again hopefully next week. Either I'm not sure Monday, but definitely on next Saturday. Yeah. All right. Bye bye. Oh wait, is the stream delay? I just want to make sure that I just see everything before. Bye bye. All right, yeah, go. All right, bye bye.